Hi guys, hope everyone is able to listen to me. If I'm audible to all of you, please quickly write it on the chat window with a yes. Great. Looks like I'm audible. Great. So guys, my name is Abhishek, and I'll be taking this session today. I have with me Rahul as well. The two of us will be helping you out in understanding, introducing you to Hadoop and specifically HDFS. Okay. YV Kumar says that it's not audible to me. Okay. I think if it is audible to everyone else, YV Kumar, you'll have to just check your internet connection and your speaker settings. Okay. Hi Devashish, hi Suman, hi Anupam, hi Yashwant, hi Vidyasagar. Uh, okay, great. So Kumar is able to hear it. Okay. Hi Rohit, hi Sandeep, Rahul, hello. Syed, Syed, how are you? Dinesh, hello. So I think it's a warm Sunday afternoon. We are expecting a couple of people more to join. Okay, so I'll just, before everyone joins in, what we'll do is we'll quickly get introduced to each other because it's going to be a long journey, 8 weeks of time, and it will be great if you can quickly write it on the chat window that, hi Gaurav, how are you? On the chat window that, what are you doing? What is your current profile? So, and I'll keep sharing it with everyone so that everyone knows what the kind of co-learners we have. Can you quickly write it in the chat window? You can just write your name we'll come to know, and you can just quickly write your experience level, what is your motivation for doing this course, and all those things. A little bit about yourself. Okay, so I'm waiting for a couple of more people to join. Usually we have around 12 to 13 people in the class, and I think we're already there. So let's wait for a couple of minutes. Okay, I have someone who has told me, hi Mohan. Okay, just give me a second. I'll read out whatever. Okay. Okay, great. So a lot of people have introduced themselves. I'll just read out. I have the first one to introduce himself is Suman. Hi Suman. Suman says, I myself Suman into IT for around 8 years and into mainframes currently with Infi. Welcome Suman. Welcome to the class. Good to have a person like you in the class. Then we have Mohan. Mohan says, okay. So my name is Mohan Gopalakrishnan. Mohan, if you can quickly tell us a little bit. Okay. Oh, Mohan is currently the head of Adobe Development Center at Chennai. Welcome, Mohan. It's good to have such a senior person like you in the class. Really, really humbled by your presence in the class. Right. Thank you very much for joining in. Then we have Devashish Kaushik. Devashish says, hi Gaurav. Okay, my name is Devashish Kaushik and I work as a business analyst for 4 years in BFSI domains in India Bulls. Great to have you, Devashish. We have Dinesh. Dinesh is working in Mahindra Satyam for last 2 years. Great, Dinesh. You're probably the youngest guy in the class, so welcome. Then we have Vidyasagar. Vidyasagar says web developer, 5 years experience working with IBM. Welcome, Vidyasagar. Okay. Syed Munawwar has total 9 years of experience, and Syed is working, I believe, in Oracle for 6 years and for identity management services. Great, Syed. Syed, welcome, Syed. Okay. Sandeep says he's an ex-Yahoo employee. Welcome, Sandeep. Welcome to the class. And I could not find. Okay. Automation framework developer, 9 years experience, Java J2E domain. Welcome, Sandeep. Welcome to the class. Okay. Then we have, we have Yashwant. Yashwant is 2.5 years of experience. Previously worked as PHP web development, currently working on mainframe technology. Welcome, Yashwant. We also have Samir. Samir is actually, Samir is going to University of Buffalo, New York, this fall for MS, and so wants to learn Hadoop and MapReduce related coding before going. Okay, great. I think there's some echo here. Just give me 1 second. I'll just take care of that. Okay, great. Okay, Gaurav, we have Gaurav Tamwar. Gaurav has 7 years of experience with Infosys mainframe technologies, working for American Express client. We are looking to shifting ardent processing part into distributed world. Oh, great. So the motivation, eager to learn new and deliver excellence. Great. So yeah, I've probably introduced everyone in the class now. We have around 13 to 14 participants in the class, which is a little overbooked from the way I recommend. I like having 12 people, but nevertheless, we'll try to answer all the questions. So what I suggest is we'll keep this a very interactive session, and we have a eclectic mix of people from multiple domains. So we'll keep looking at the chat window. You can keep writing your experience and yeah, Rahul. Rahul, just give me a second. Yes. So to start with, we have everyone is on mute now. Okay. If you want to speak, you will be allowed to speak. You can just raise your hand, and you'll have to make sure that you have a clean microphone and you don't have any background noise. So if you're sure with that, then we'll get you started on that. We'll unmute you and you can speak. I'll allow one person at a time to speak so that there's no background noise in the class. Okay. Is that fine? So I have Rahul Tiwari. Rahul Tiwari, really sorry for not responding back earlier. Rahul has experience around 6 years, works on Teradata, Informatica and business objects, currently working with Mahindra Satyam. Rahul, which city are you from? Okay, Mohan, yes, you can test your mic at your end. If you want, I can just allow you Pune. Rahul is from Pune. Guys, there may be a lot of such things. Since this is live, I'll be talking to multiple people, so please don't mind if a question is not answered. Please feel free to write it back on the chat window. So Mohan, what I'll do is I'll unmute you. You can also introduce yourself to the audience, and that way you'll test your mic as well. Is that fine, Mohan? Okay. So Mohan, I'm just unmuting you. Please make sure there's no background noise. Okay, so we have Mohan on now. Mohan, can you quickly introduce yourself? We are eager to hear about you.
Can everyone hear me?
I can hear you. Yes, everyone says yes,
okay.
Mohan.
Okay, good. My name is Mohan Gopalakrishnan. I am currently, and I'm using the word in a very translating way, I'm currently the head of Adobe Chennai. I mean, of course, I was part of a startup called Efficient Frontier, which was acquired by Adobe. I was the managing director for that. So that's how I got to be head of Adobe Chennai. I've been with Adobe and Efficient Frontier for the last 4 years. Prior to that, I used to be a director at Oracle, both in the US and in Bangalore. I was also heading a startup called Spike Source. I have worked at Symantec. I was the author of the first 2 versions of Norton Antivirus. So that's kind of my background. I've had about 24 years of experience. The reason why I'm here is because I no longer have a technical hands-on role, and my one way of coming up to speed on the internals of something like Hadoop is to attend a class like this. And we use a lot of big data in our work. We haven't yet moved to Hadoop, but we use similar technology, homegrown technology, and so on and so forth. So this is for me a way of getting a segue into technical stuff, doing something hands-on, and getting into more details about things.
Great, Mohan. I'm really humbled to have you in the class. I mean, you're probably the senior most person who has attended this class, and I hope you will have a great experience with us, and we'll be able to also learn with you. Okay. Welcome to the class. Can everyone? Yeah. So there are a lot of people who are saying, great to have Mohan. Can I have everyone giving me a smiley on that to have Mohan in the class? Can you quickly give me a smiley? Yeah, we have Rohit Malik who says that, Vidya Sagar. So Mohan, everyone is happy to have you in the class. So welcome.
Likewise here, there's nothing to feel humbled. I mean, I'm learning. I mean, so I probably will be the slowest learner here because I haven't done hands-on technical work in 10 years. So let me hope I learn as much as I can.
Don't worry, sir. We'll be there to help you out, and whatever help you need. We do have a 24/7 support team. So this is for everyone. Anyone facing any problem after the class, we have a 24/7 help desk where you can come. You can get one-on-one live support. So any problem you're facing, show your screen. These guys will help you out. Okay. So okay. So now I left Rohit. I'm really sorry, Rohit. Mohan, I'll put you on mute again. Is that okay?
Okay, no problem.
Sure.
No problem.
Anytime you guys want to come back and speak, please feel free to raise your hand. There's a hand raise tool in Citrix there. Okay. So Mohan, I'll keep you on mute then. Okay. Yeah, Rohit, I'm really sorry, buddy. I could not introduce you then. I just, there's so many people introducing them. So Rohit is again a very experienced. He has around 14 years of experience in IT, mainly in TIPCO and integration areas. And my motivation is to get into analytics and big data, which is the future of IT. Well, definitely, Rohit, we also believe that this is the future in IT. So welcome to the class. And if you would like to introduce yourself on chat, I would like to just, I can unmute you. If you'd like to do that, just give me, just let me know in the chat. Okay, fine. So Mohan, Rohit is fine. He doesn't want to speak. That's what I understood. And anyone else who wants to introduce himself on the mic, or who wants to test his mic by introducing himself, you're most welcome. You can just quickly write on the chat window in the next 2-3 seconds, and I'll unmute you, or else I'll get started. So is there anyone who wants to introduce himself? Anand Kumaran is saying hi to Mohan. So I'll pass it on. Okay. So let's get started. I mean, don't worry. We will have more opportunities to talk to each other. Okay. We'll have more people and we'll have more opportunities to discuss. We'll unmute you in between. Okay. Let's get started with the class now. So everyone, and in between class, if for some reason you're not able to hear me, you can write it down on the chat window, and we'll have someone help you out if from the technical team itself. Okay. For any reason, if some of your questions are not answered, if there are a lot of questions, the support team looks at each and every question, they respond back. You can also send the question on support@edureka.in, and there'll be someone to help you out. Okay. So let's get started, guys. So before I get started with the technical stuff, I'll tell you how this course proceeds. Can I have the chat window here? Okay. So the week 1, we will that is today. We'll start with HDFS. HDFS is the Hadoop distributed file system. Don't worry about it if you don't know about it yet. You will be introduced to it during this session, and I can assure you that by the end of it, you will become an HDFS expert, definitely, to speak about it. Second week, it will be completely hands-on. We'll be running, setting up the Hadoop cluster and running HDFS commands on that. In the third week, we'll move on to MapReduce. MapReduce is the programming model in Hadoop. Don't worry about it right now. If you don't know that, we'll take care of that. And then we'll move on to Pig, Hive, Zookeeper, Scoop, HBase, and all these things will be covered each week. Okay. So this is how the course will flow. Now, one thing which I want to tell everyone here is that for MapReduce, you may need to learn a little bit of Java. So if you're not from a Java J2E background and you're keen to go hands-on, dirty your hands on MapReduce programming, then you can, there's a free Java course which happens during this course. So you can attend that. Probably the classes happen during the weekdays in the evening. You can ask the support team, they'll set up a class for you. Okay, so anyone like that can directly talk to the support team. At the same time, it's not mandatory to learn Java or to get deep into MapReduce, because most of the people in the analytical world will be actually looking at tools like Pig and Hive in their normal jobs. Okay, so it's okay even if for some reason you're not able to, you don't want to get into Java in depth. Okay. And please, guys. Sorry, I got muted. Guys, if for some reason you're not able to hear me in between, yeah. Okay, Mohan is asking about my background. Mohan, I've been in the IT world for last 10 odd years, okay, and been working on Hadoop for a couple of years. So that's pretty much about me, and you'll come to know more about me as we proceed in this class. Okay, so yeah, so as we get started, I'll tell you a few things to make this session. My name is Abhishek Mohan. Yes, for everyone, my name is Abhishek. I have Rahul with me. Okay, so one thing which I wanted to tell you guys is that you can keep writing on the chat window. If there are any questions which come to your mind, don't hesitate pushing on the chat window. I'll take logical breaks in between during the session, and I'll answer all the pending questions. And when I ask you that whether you were understood or not, don't be lazy, just write yes, so that I know that you are with me. So are you guys with me? Can you quickly respond back with a yes? Till now? Great. So it's, some people, okay, great. So all of you have written yes. Okay, thank you, Anand. Thank you. You need not write such long sentences. You can just write a S, or I like a smiley much better than anything else. So you can give me a smiley if you like me. If you are hating me, then you can give me a reverse smiley. Okay, Yashwant has given me a smiley, so he's liking the class. No one else is till now. Let's hope that we get a lot of smileys during class. Okay. Okay, I got a lot of smileys. Okay, Vidyasagar has given me a big happy face. Thanks, Vidyasagar. I love you, buddy. Thank you, guys. Okay, so let's get started, and I hope we'll keep this interactive. Thank you, Vidya. Okay, so and I'll keep making fun of you guys. Okay, during the class, so that it doesn't become boring. It's a long class, so if you're planning to eat something, please grab something to eat or drink. Keep it in your desk. No one's going to see what you're eating. Okay, so I don't have the liberty to do that, but I'll try to grab something in the middle of the session. Okay, so let's get started, guys. Okay, so this is where now we have a picture here. We have a few pictures here. Okay, let's see if and the slide says what is big data. Okay, so now everyone knows about this, I believe, right? Facebook is the probably the biggest company which will be having the most amount of data being generated every day, and they do a lot of analytics over it. So this is very clear that now the amount of data generated by Facebook is around, and this is definitely an old figure. It says 500 terabytes of data per day. Okay, so this is the kind of data being generated by Facebook every day, and we'll very soon understand that what are the challenges in crunching this data, what are the challenges in analyzing this data. Okay, so let's look at the other picture. Can anyone tell me why have I put an aeroplane on this? Quickly, guys, I want you to answer this. Can anyone tell me why have I put an aeroplane picture here? What does the aeroplane or airline have to do with big data? Where is that data coming in? Gaurav, can you tell me what data are we talking about in airline? Maybe flight traffic. Okay, what else? Flight bookings is what Gaurav says. Okay, I'll keep on repeating. I want everyone to actually, okay, passenger details. And the reason this is very important, because big data is not every kind of data cannot be treated as big data, and Hadoop cannot be used on every type of big data. Okay, so it's very important to understand, people are answering these questions with data from passenger details, passenger data, okay, data generated by plane. If something goes wrong, which will use to analyze further. So Rahul has come up with a very interesting answer. Rahul says data generated by plane, if something goes wrong, which will be used to analyze further. Rahul, yes, that's right. And has everyone heard about a black box in a plane? Yes or no? Can you quickly tell me if someone has heard not about black box? Has everyone heard about black box? So a lot of people have given me answers like maybe the speed of traffic. Rohit, do you have a opinion on that? What could be the? Okay, so okay, now see, I'll tell you one thing. Rahul, your answer is right. The reason I put it here is because I wanted to see. The reason why this airline picture has been put is I believe someone is telling me that they're not able to hear me. Am I with you guys? Are you able to hear me? Or okay. So maybe someone lost the connection at their end. No problem. Okay. So yeah. So basically, Rahul, your answer is right, and I also explain why the other people who have given answers like passenger preferences, passenger data from passenger details, flight bookings and all. Just note down all these things in your mind. I'll answer very quickly why this cannot be termed as big data. Okay, and this can be, but in this case, what we're talking about is the data which is dumped by a flight while it is running from, say, New York to London. Okay, so Rahul, your answer was right. It is the logs which are being generated by the engine and the airline. Now, can you tell me, can someone tell me what could be the quantum of this data? So as Facebook was generating 500 terabytes of data, can someone tell me what will be the quantum of this data? Can you make any guesses here? Rohit, I want a guess from your side, man. You must be traveling a lot in the last 14 years. Can you make a guess? Can someone make a guess? Oh. Okay, we're getting a lot of answers. Rahul, I think Rahul already knows everything here. Rahul, where did you do your engineering from, man? Where did you study? Okay, each flight around 5 to 10 GBs is what Gaurav says. Okay, Rahul is asking me a question. Okay, Rahul is smiling at me. Vidyasagar tells me in petabytes. Okay, what I want to know is not only what data, but I want to know in how much time, how much data. Okay, so I mean, yes, it will, Rahul. Okay, so in petabytes is what Vidyasagar says. Vidyasagar, can you tell me how many petabytes every day or every hour? Any idea like that? Syed Munawwar says geometric. Okay. Anand says 100 terabytes per day. Okay. And I have an answer. 15 petabytes per day is what Devashish tells me. Okay. So guys, let me give you an answer. Let me give you I know this answer because I have prepared this slide. There's nothing more about it. Okay. So the answer is that it takes, for every half an hour flight, right? For every half an hour flight, it generates around 10 terabytes of data. Okay. Which means that approximately the same data as Facebook dumps in a full day, airline also dumps that much data. One aeroplane, if it runs for 24 hours, dumps a similar amount of data, right? So did you really think that it would be so huge? One aeroplane dumping equal data as Facebook. Did anyone actually think that this will be the thing? But when I came to know about this figure, okay, great. So yeah, quite a few people have, okay. Gaurav Tanwar says unbelievable. Okay, yeah, yes, Gaurav. So geographical, weather condition, run stats, mechanical rate, subject, yes, everything. So everything is dumped. It is not used all the time. We don't crunch this data. We don't analyze this data all the time. But as Rahul pointed out, Mohan said, I thought it would be more. Okay, Mohan, great. So basically, I think one thing which is very important to understand here is that dumping this data is one thing. The next part is how do we analyze this data. So for the flight information, this flight data, we don't analyze all the time. If there's a mishap, then only we analyze. Okay, so Mohan had expected more, but airline actually did not meet his expectation. That's fine. And okay, next, what do we have here? The third picture. We are going what, clockwise or anti-clockwise? Okay, so Sandeep, the point of storing the data is, if in case of a mishap, if we have to analyze this data, then we'll come to know what really was the reason for the crash. So that is where Sandeep is asking me, then if you're not analyzing this data all the time, then what is the point of storing the data? Yes, Mohan, it is tied to sampling rate, but I'll answer that question in a while. Sandeep, is your question answered? Okay, great. So guys, if you have any question on this, I can answer it, or let's move on to the next picture. So what is this? Why have I put this electric pole? Electric transmission is what Rahul says. Rahul is the fastest guy. Okay. Gaurav has also, Gaurav, your typing speed is great, man. Electrical power grid system, nationwide connections should be used data. Yes, exactly. Right. So Gaurav has given us an answer. It says electric power grid system, nationwide connections should be used data. Yes, it is used data. Rohit says tariff. Yes, electric tariff also comes in. And a lot of information about which node is consuming how much electricity, right from the bulb at your home to something as big as a generator or something running or an industry. The electricity department or the power grid needs to know where exactly. Yeah, exactly. Syed Munawwar gives me an answer. Flow of current from one point to another, right? Yes, Rahul Tiwari says fight between two states for electricity, right, Rahul? So, yes. So Rahul, yes, Rahul has given me that answer that we need to analyze this data to resolve the fights between two states for electricity. So does everyone, I mean, can everyone appreciate this answer? Can I have a smiley for this one? I want to give a smiley for this. Okay, good. Some people are happy with you, Rahul. Not everyone is. Okay, a lot of people are happy with your answer. Okay. I think Mohan is not. Mohan is not happy with your answer. Maybe Mohan doesn't. Mohan is also happy. Okay. So everyone is happy with your answer. If there is anyone who is not happy with Rahul's answer, you can make a bad face at me. I'll not tell it to Rahul. Okay. So yes, that's right. Lot of data being generated by the power grid system and to analyze. And finally, let's take it just to resolve the electricity fight between two states. Right. Now, what is this? The fourth picture here. Stock exchange. Okay. So which stock exchange? Vidyasagar, which stock exchange? Okay. Everyone knows this answer. Everyone knows this. Yashwant is smiling at me. Okay. Why is so this is NYSE. It's there in the picture itself. There's the National Stock Exchange. Okay. Great. Now, so it is not the National Stock Exchange. It is the New York Stock Exchange. Now, this also generates huge amount of data. Okay, and this is another example of place where big data is getting generated. So the idea of this slide was to introduce you to various scenarios where we are generating big data. Now there are other examples like LinkedIn, Amazon. A lot of companies generate huge amount of data, and that is largely unstructured data. Now I have a lot of people from the Oracle background here. They know the difference between structured and unstructured data. Could anyone like to explain that to me? What is the difference between structured and unstructured data? And I can unmute you as well if you want to. So we would like to have people actually pouring in their opinions, because we'll all learn together. So anyone who wants to answer that question, difference between structured and unstructured data? Rahul Tiwari knows all the answers. Rahul, are you Oracle? Is your middle name Oracle? Can we? Okay, he is from Teradata. Okay, so so anyone else has the answer to that difference between structured and unstructured data? Only Rahul has the answer. Okay, so no one else is willing to answer. Is this very? Okay, so is it becoming too boring for every? You can't hear me. Okay. Okay. No, I take breaks. I cannot speak continuously. So Gaurav Tamba says, from mainframe point of view, I can understand structured data, which can be described as a fixed layout. Okay. Do not know exact answer. Okay. Great. So Sandeep says, do not know exact answer. So guys, I really appreciate if you write something on the chat window so that I will come to know that you are there. Okay. So if you don't know, yes, can everyone who doesn't know structured and unstructured data? Can you write a no if no one knows about it? It's very important to understand. There's the first concept here. Okay. A lot of people want to understand that. No problem. Okay. So let's try to understand what unstructured data is. Rahul, do you want to tell everyone what unstructured data is from your Teradata experience? Can I unmute you? Rahul, are you with me? Would you like to speak, or you want me to answer the question? Okay. So basically, Rahul has answered. He doesn't want to speak, but Rahul has answered the question in the chat itself. Rahul says unstructured data is the data which is in the form of logs. So there are no tables, there are no rows and columns in the data. It's just plain logs which are being dumped. That's called unstructured data. Okay, is that clear to everyone? That's the right answer, and I'm sure a lot of you people would have guessed that. So big data, example again, yeah, all these answers, Sandeep, the data which Facebook dumps, right? All the whatever activity you do on Facebook, the like, share, whatever you're doing right now, you're writing these things, the logs of this class are also unstructured data, right? Whatever you're writing in the chat window is getting in as a unstructured data. Is that clear to everyone? Does that suffice? Sandeep, does that answer your question? Okay, great. So that is unstructured data. Structured data is in the form of tables and rows. And when I said that I am not interested in the information of who has booked the flight and whether the flight updation is happening, The reason why I said that was because that is structured data. That is stored in terms of rows and columns and tables. So that is why I said the data which we are, big data right now, whenever we talk about big data, we're talking about in the context of unstructured data. Is that clear to everyone, sir? Anyone who is not clear with this can quickly say no. We are going a little slow, but that's fine with me. Okay, great. So it's clear to everyone. Can everyone give me a smiley if it is clear to everyone? Suman gives me a smiley. Okay, Dinesh also is giving me a smiley. Everyone is giving me a smiley. Mohan, is that okay, sir? Ajay, okay, we have Ajay also in the class. Ajay, can you quickly tell us what do you do? I think you are a new entrant in the class. Okay, great. So Ajay, can you quickly tell me what do you do? You want me to unmute you? Can you speak? Do you want to speak out? Okay, you can type. So yeah, Ajay says I am into data analytics. Okay, Ajay, what do you do exactly? Would you like to tell us more about yourself? While you type, I'll answer Sandeep's question. So Sandeep, yes, you use your FB account, but at the same time, it will be going as a yes. So it goes into unstructured data as plain files. All the logs in FB, okay, go as the unstructured data as plain files, and we'll know more about it as we proceed in this class itself. And it is stored in Hadoop, basically. FB uses Hadoop. Okay. So okay, great. So now Ajay has introduced himself. Ajay says, I'm into analytics using R and SAS. Great to have you, Ajay. I think R and SAS is again very relevant to this topic. So what is your motivation of attending this Hadoop class? You can write it on the chat window. I'll read it out as we proceed in this slide. Okay. So yeah. So the idea of this foil was to introduce you to what is big data and to make you understand that it is actually unstructured data. When we talk about big data, we are always talking about unstructured data. Okay. So is that clear to everyone? That huge amount of data which is unstructured. Okay. A huge amount of data can be structured, but the huge amount of data, when it is structured, is not termed as big data. Okay. So now, okay, Ajay has introduced himself. Ajay wants to learn this, learning how to analyze huge amounts of data by understanding how it is used within Hadoop. Great. So Ajay, where do you work for? Which company do you work for? If you want to tell us that, you can tell us that, and while I move on to the next thing. So can anyone tell me what is this? What is this fifth picture here? Rahul, you know everything, buddy. I think, okay. Okay. Yes, a lot of people are giving me answers here. So, okay, we say a few interesting answers is, Ajay says, I work on my own. So Ajay, you're running a company of your own? Great. So you're an entrepreneur. Great to have you, Ajay, here. Okay, so Sandeep Ganguly says files. Rahul Tiwari, I'll read out your answer. Dinesh says files. Yashwant says big data, pile of files. Gaurav says files of data, data increasing day by day, says Samir. We can say unstructured data, says Syed Munawwar, right? And data in hard files, says Rohit Malik, hard copy. Office files, says Devashish Kaushik. And we have Vidya Sagar, which says pending files in government offices. Right. And Rahul also says looks like files in Indian government offices. Right, that's the motivation of putting it here. There's a lot of big data kept in Indian government offices, which Hadoop also cannot help in analyzing. So this is this yes, that's the reason I. So yes, Sandeep Ganguly says great. Devashish Kaushik says hey. Sandeep has given me a smiley. Anyone else who liked this humor can give me a smiley. If you hated this, if it was a poor joke, you can give me a. Rohit says gives me a smile. Okay, so everyone is happy. Looks like Mohan is not happy. Gaurav says good one. Rahul Tiwari says name a man named Hadoop to analyze these files. Okay, Mohan is not happy. Okay, Mohan says just lazy to type. Mohan, you're typing so much, man. You can just give me a smiley. Okay, that would be a lazier way of doing things. Okay, so everyone liked that joke. I also liked that joke. Ajay did not like that joke, I believe. Ajay is a author, so he doesn't like these jokes. No problem. I'll crack another one, Ajay. I'll try to get praise from you. Ajay has given me a smiley finally. So I am actually very adamant on getting smileys. Great. So yeah, guys. So so now from this slide, what we have understood is that there are companies, we have huge amount of data being dumped, okay, and a lot of this data is unstructured data. That's the second thing we understood. And if the data is in terms of digital format, then we need to make sense out of this. We need to do some analysis over it, and that is what big data analytics is all about. And now we'll understand what is the challenge with such amount of data. Okay, so and we'll move on to the next slide for that. So if everyone has understood these 3 points, that we're getting huge amount of data being dumped by a lot of companies and organizations every day. The second point, that the difference between structured and unstructured data, and we need something to solve this big data problem, then I'll move on to the next slide. Okay, is that fine? Everyone, yes? Can you quickly type a S on the chat window if you want me to move on? Okay, everyone is giving me smileys. Great, great, very good. Thank you very much, guys. Okay, okay, so let's move on. Let's move on. Yes, yes, Rahul. Yeah, what I mean is, it cannot, Rahul says, is Hadoop always require digital data? Yes, I mean, you need to have data in some digital format, right? Can you analyze government office files with Hadoop? No, you can't, right? So that is what I meant by that. Okay, so next, let's move on. Okay. Now we've understood that the amount of data being generated. Let's see what is the real challenge. I mean, what is the real problem? Now we have so much, storing data is not a problem at all. Everyone has 2 TB, 5 TB hard drives in their homes. So what is the challenge? The challenge here will be explained by this example. So let's see, we have this traditional way of storing data where we have one single machine on the left hand side, okay, which has 4 IO channels, which means it has 4 hard drives, okay, and each hard drive can run at 100 MB per second. So the challenge here is, let's see how many of you can tell me how much time it will take to read this 1 terabyte of data from this machine. Can everyone try this out? It's a maths problem, and so the challenge is 1 terabyte of data, 4 parallel reads happening, okay, through 4 hard drives, and each channel reads 100 MB per second. Most of you guys are engineers. I want you to just quickly get back to, you can use a calculator as well. Okay, we have an answer already. So Syed, I'll reveal your answer very soon. Anyone else can answer? Okay, Yashwant has also given me an answer. Guys, you're quick. Okay, Suman has given me an answer. Suman says, I want that answer in minutes. Okay, I want that answer in minutes. So the question is, and I want everyone to try this. Everyone has to give an answer. Whoever doesn't give me an answer, I will not allow them in the class. Okay? Okay. So I have an answer from Anand Kumaran, who says 170 minutes. Rahul Tiwari says 3 seconds. Rahul, you are really fast, man. It cannot happen in 3 seconds. Okay. Suman says 2500. Okay. A lot of people have given me the right answer now. Okay. Ajay tells me 10.24 seconds. Ajay, can you quickly explain me how did you arrive at that? Quite a few people have given me answers like 45 minutes, 43 minutes, 40 minutes, which approximately is the answer, but I would still like to understand from Ajay, how did he, okay, Sandeep is also giving me an answer, 40 minutes approximately. Okay, Ajay, how did you arrive at 10.45? Gaurav means, okay, so yes, see, the thing is that the way the calculation is simple. Can those people who have given me an answer around 40 minutes quickly write on the chat window, or you want to explain to everyone how did you arrive at that number? Okay, Ajay has given me an answer. 1 terabyte is equal to 1024 GB, 1024 into 1024 MB, and then he's doing some calculations and he'll arrive at some answer. But before that, can Gaurav or Vidyasagar, would you like to speak? You've been answering a lot of questions. I'll let you answer that. Okay. Samir has also given me the right answer. Okay. Syed says, I've done this once. Okay, great. So Vidyasagar or Syed, any one of you want to tell us? Okay, fine. So it's actually very simple math. You have 100 MB per second. Has everyone, Vidyasagar gives me an answer, 100 into 100 divided by 4. Right. Yashwant, you're also right. So I think everyone has understood that. Anyone who is still not understood this? Anyone who has not understood this? Mohan, are you with me? Okay, Devashish says, I want to understand. Okay, so Devashish, as so many people are explaining here, so to read, think of it this way, you have to read 250 gigabytes from each hard disk, right? So that is the total number of amount of data which you have to read in parallel, because there are 4 channels, so each channel can read 250 gigabytes, and 100 MB per second is 250 gigabyte divided by that 100 MB per second, and that comes to around 45 minutes. Is that clear, Devashish? Does that make sense? Okay, great. So everyone has understood that. So basically it takes around 45 minutes, 43, 40, everything is fine. Sayyid Munawar gives me a smiley. Thank you, Sayyid. Okay. So now think of it this way. Now this is huge amount of time. And I was assuming a very good hard drive, because 100 MB per second is almost the speed which SATA runs with. Okay. So now if you had to say analyze around 500 terabytes of data, do you think it is possible to do it at all using this method? It's completely impossible. Every day you will not, it will take years to actually read that data. If not years, then at least days and months. Okay, so what we'll do, what is the solution then? Can we look at the figure on the right hand side? What we do here is that we divide this data, we partition this data into 10 parts, okay, store the 10 parts in different machines, okay, and then we try to see how much time it will take to read. And this is a very, very simplistic view of things. It is not all that simple, but assume to start with, let's assume that we had this 1 terabyte of data divided across 10 machines, and you are reading in parallel from everywhere with 4 channels in each machine. So can someone give me an answer? What will the total time taken now? Okay, so everyone knows that answer, divide by 10, right? So approximately that much time. So now you understand why do we need a distributed storage? Does everyone understand why do we need a distributed storage? Well, everyone is giving me a yes. Now the challenge which I want to reiterate again, Rohit, thank you very much. Mohan, thank you. The challenge which we are facing right now is not the storage capacity. Storage capacity have scaled up. Okay, what has not scaled up is the IO speed. To overcome that and to take care of that trade-off, we have this, we need a distributed file system. Is that clear to everyone? The challenge here, the IO speed is the challenge and not the storage capacity. Okay. So if everyone has got the point on this slide, I'll move ahead. Can give me a smiley quickly. Okay, great. Rahul has given me a double smiley. Okay, Anand is also happy with me. Ajay is happy with me. Devashish, Anupam, everyone is happy. Great. Okay, guys. So let's see. So let's move on. Let's see then so we've understood now here is that to do this big data analytics, we have to figure out a way of putting this data across multiple nodes. Okay, when I say nodes, don't worry about what I keep on introducing jargon in between, and I'll explain it. Don't worry if you do not understand what a node is. I'm sure everyone can guess what a node is. But we have to distribute this data across different machines or nodes. Okay, and that looks like a probable solution to solve this problem of analyzing or crunching this huge amount of data. Okay, so let's see how are we. So it takes 4.5 minutes, and let's see what a distributed file system is. So we have understood what why do we need a DFS. Now let's understand what a DFS is. So here what you see on your left is 4 machines, 4 storage devices sitting at 4 different locations. Okay, and once, so they have their own file system. They're physically separate machines. Okay, after I create a distributed file system out of these, what I'll get is something like this, where at the top of it will look like we are accessing a single file system, but underlying hardware is sitting at different places. Okay, at a logical level, they all come in a directory structure. So if you look at your Windows machine, it will look like there are multiple directories which we are having. Does that make sense? Is that making sense to everyone? That what is the difference between how will this physical thing get converted into a distributed file system? We will look into details, but just to give you an idea, this is how it will look like. Okay, Great. A lot of people are giving me smileys. If there's anyone who has not understood this, I can quickly tell you again. So 1, 2, 3, everyone has understood. Great. So everyone has given me smileys now. Great. Some people are getting lazier. Okay, Ajay says, please, once again. Sure, Ajay. So Ajay, see, there are these different machines which are sitting at different physical locations. Okay, different physical locations. And what I do is, if I create a distributed file system out of these, physically these machines are still at different locations, but logically, at a logical level, I've created a file system where all these machines look like they're a part of a single file system. Okay, so as we saw in the last slide, that we have to have multiple machines from where multiple reads can be done in parallel. So to solve that problem, we used multiple machines, not a single place to do I/O, but at a higher level, at a logical level, at a directory structure level, they become a part of a file system. Is that clear, Ajay? Does that make sense? Great. Thank you very much. So everyone is clear with this. Syed says, gives me a smiley. Thank you very much, Syed. Really appreciate all the smileys which you're giving me after every point. Thank you. Thank you, Anupam. Thank you very much. Anupam, you came in a little late, I believe. We did not get introduced to you. But don't worry, you can write your introduction in the chat window. I'll introduce you once I get to a logical break somewhere. Okay. So don't worry, Rahul, you'll get these answers. Don't worry. I'll answer all these answers. Okay. Don't worry about them right away. Rahul asking me some technical question which I don't like. Okay. So I'll not answer this right away. I'll answer that later on. Okay. So yeah. Okay. So what is Hadoop? Now we've understood what is big data. We've understood what is the need of unstructured data. We've also understood that the challenge is not to store data, but to read-write data, to analyze data. And we've also understood to do something like this, we need something which can support a distributed file system. Okay, so Hadoop is actually a framework which solves this problem. Okay, so all of you understood the need for Hadoop now. Can you quickly give me a yes? I'll understand what is you'll understand what is Hadoop, but has everyone understood the need for Hadoop? Anyone who is not? Okay, can I get a smiley from everyone? Okay. A lot of people are writing and smiling as well. Okay. Okay. So Rahul says, can you repeat? Rahul, are you joking with me or you really want me to repeat? Okay. So I'll just repeat it for the sake of Anupam and everyone. So see, basically, who've joined late, we've understood right from the first slide that what is big data. We've understood that. So we have huge amount of data, unstructured data getting dumped in some places. Okay. Then we understood that the challenge is to analyze this big data, we have to read it back. Okay, Rahul, please pay attention here. Now, the challenge is not to store the data and how to store the data. Technology has scaled up there. The challenge we saw was to read that data back, okay, to do analysis on it. And then we understood that reading it from a single place is not going to solve the problem. So we understood that there has to be some distributed way of storing this data. And then we understood what a distributed file system is. And now, so we know that there is a need for something which can solve this problem of storing data in multiple nodes across a cluster. So is that clear to you, Rahul? That is why we need Hadoop. Great. So that is okay, great. So now the need of Hadoop is this. Everyone has understood that. Let's see what Hadoop is. I'll go with a formal definition of Hadoop, and this will, I promise you that this is the last formal definition I will talk about in my whole life after this one. Okay, I hate formal definitions, but this time I had to put this in. Okay, so Hadoop is a framework that allows for distributed processing of large data sets or running on commodity computers using a simple programming model. Okay, so now there are a few things which have to be noted here. Okay, that's why I put this definition. So Hadoop is a framework that everyone understands of distributed processing of large data sets. So Hadoop is useful only when you have large data sets. Okay, if you have small files, it is not of use. So this is a very important thing, large data sets, and that too unstructured data. Okay, across clusters of commodity computers. Okay, I'll make you understand this term also, commodity computers. So basically, Hadoop does not require the nodes on the Hadoop side need not be high quality, high availability machines. They can be simple hardware, commodity hardware. We'll understand this in more detail using a simple programming model. So the simple programming model is called MapReduce. I will not explain you anything about MapReduce today in today's class, but you just try to understand that there is something called MapReduce. Just get this term in your head. In the next few classes, we'll understand that in more detail. Okay, is that clear to everyone? So it's a framework for distributed processing, large data sets, commodity computers, and simple programming model. So we will understand each and everything in detail going forward. Is that clear to everyone, guys? Anything which you do not understand here? It's very important to understand this. Great. So yeah, I think everyone has understood it. Okay. So good. Thank you, guys. If you keep on giving me these yes or smiley, I know that I'm doing a decent job here and you're not getting bored. Okay. So please do not hesitate to write that. Okay. Thank you very much, Ajay. Mohan is not doing that. Mohan is not happy anymore. Okay. Don't worry. There are enough people to keep me going. Sayyad has given me a smiley again. Thank you, Sayyad. Okay. Mohan is saying not true. Mohan, you can just give me a smiley, man. Okay. So now companies using Hadoop. Now this is again a question which people ask. Which are the companies which are using Hadoop? So I'm sure a lot of we had Sandeep from Yahoo, right? Okay, no problem, Mohan. Please take your time. Okay, so Sandeep is from Yahoo. So Sandeep, Yahoo is a company which uses Hadoop. Google uses Hadoop. Facebook uses Hadoop. Amazon, IBM, AOL, a lot of other companies. You can find that here. I mean, LinkedIn also uses Hadoop. So basically, the funda is that any company which has to do a big data analytics, and we have an expert on big data analytics here, Ajay. Ajay, can you tell me one Indian company which is using Hadoop? Ajay, okay. So Google says, okay, yes, Vidyasagar, that's right. Google had released their own version of DFS. Sure, Rohit. Not today, but definitely we will understand it. Okay, not today. Okay. Cloudera is not Indian company. Thank you. Okay. So with Vidyasagar, yeah, Hortonworks is also not Indian, I believe. EMC is also not Indian. Well, I have been told that the Aadhaar scheme is going to use Hadoop. Okay. So Aadhaar scheme, everyone knows about that? Does everyone know about that? Okay. So Aadhaar scheme is going to use Hadoop. So that will probably one. Okay. So now guys, there may be some answers which I may not be able to give you right now. And the reason why I don't want to give those answers is maybe they will take you a little off topic. So I'll not answer them right away. You can always write those answers on the chat window. We'll respond them offline. And also, if needed, we will be covering a lot of those things as we move on in these sessions. Is that okay with everyone? Okay, cool. So yes, these are the companies which use Hadoop. Okay, so now let's move forward. Now I have this is the first technical diagram on my slide. Okay, and I want every one of you to actually look at it for some 10-15 seconds and don't worry too much about it for now. I bet that by the end of it you will all become experts in this. Okay, so Hadoop basically has two core components. Okay, I want all of you to actually look at this pay a lot of attention here. Okay, because this is the first time when we are talking about Hadoop, and that's why you've paid for. So if you don't understand this, there's no point in your making this payment to Edureka, which is, by the way, doing very good these days. I've seen the kind of attendance and the kind of demand there is. So just joking, I'll ask them for a hike. So yeah, so basically we have two major components. One is the HDFS, which is the Hadoop distributed file system, and the second one is MapReduce. So distributed file system is used for storing, and processing is done by MapReduce. We will talk about MapReduce later on in the next few classes, not today. On this diagram, there are two things which are very important to note. We said there is and I'll not explain it here. Okay, just note that there is something called a name node, which is the admin node. It's a master slave kind of configuration. So there is something called an admin node or a name node, which is the master, and then there are slaves which are called data nodes. Okay, and then there is something called a job tracker. You have to remember these terms. Don't understand them, just remember them, which is associated with a name node. and there is something called a task tracker which is associated with a data node. Okay, is that clear to everyone? You don't have to understand it completely. This is what we are here for. We'll understand it by the end of this session. For now, just remember that there is something called a name node and a job tracker which are associated, and there is something called a data node and a task tracker which are associated. Okay, and name node is the master and task data node is the slave. Is everyone clear with that? Quickly, can you give me you don't have to understand it completely. Even if you don't understand it completely, if I ask you a question, what is name node associated with? If your answer is job tracker, then you're good enough for this slide. Okay. So can everyone quickly answer what is name node is the master? Rohit gives me the answer. Name node is the master, and there's a job tracker associated with it. What is the job tracker? What is the name node is something which we'll cover. Good. Great. So yes, so data node is a slave and this. Okay, so there's another term here. Don't worry, Sandeep, I'll explain it. Sandeep asks me what is the difference between MapReduce engine and HDFS cluster. Okay, so basically HDFS cluster is the name given to this whole configuration of masters and slaves where this data is stored. Okay, so that is the HDFS cluster. So this whole thing is a HDFS cluster. MapReduce engine is the programming model which is used to retrieve and analyze this data. Is that clear? And I'll not tell you anything more than that in this. You don't have to understand anything more than that. If this much is clear, you will understand everything going forward. I'll not go into more technical details right now. So 2-3 things on this slide. One, there's something called a name node, associated job tracker, something called a data node, associated task tracker. Then we have a HDFS cluster, which is the combination of these name nodes and data nodes. And then we have a simple programming model, which is called MapReduce engine. Is that fine, everyone? Can I quickly get a smiley from everyone other than Mohan, because Mohan does not want to give that? Yes, Rahul, you're right. Rahul is asking me job tracker as task tracker, and task trackers all are separate machines, total 5 in this picture. So yes, a task tracker is associated with each data node, so multiple data nodes and single name node. That is the very minimal configuration. We will talk more about it as we move forward. Okay, so I've got a smiley from everyone. Thank you guys. Okay, so everyone has understood it. Now let's move on. Okay, so now basically there are a few features of HDFS which are very important to understand. Okay, and there may be some reiteration here, but it's very important, so I'll repeat it if required. So number one, it should be highly fault tolerant. Okay, and it is built in the system. I mean, see, we've talked about using a lot of data nodes to store data. So basically, there's a good chance that some of these nodes can become faulty over a period of time or at any point of time. So the system, the distributed file system, SDFS, should itself have a mechanism to make sure that it is highly fault tolerant. Okay. For that, what we do is we replicate data on multiple machines. So a single data block is not stored in a single machine, but it is stored in a minimum of 3 machines. We will know more about it, but that's the way Hadoop makes the system fault tolerant. Is that clear? So by replicating the data, okay, in multiple data nodes, and not by using very high quality machines, high availability machines. Okay, is that clear to everyone? First point, quickly, can you give me a smiley or a yes? Okay. The second point is high throughput. High throughput is something which is very clear because we've just seen an example that if I use a DFS, then I can reduce the amount of time it takes to read the data by 1/10 if I have 10 node cluster. If I have a 100 node cluster, I can reduce the time by 100 times approximately, not exactly. And if Yahoo uses something like a 5,000 node cluster, so you can imagine how fast the throughput can be by using this simple mechanism of distributing the data across different clusters. Is that clear? How does it achieve high throughput? Okay, great. So then, okay, Sandeep says no. So Sandeep, throughput is the amount of time it takes to read the data. Okay, and by putting data across in parallel and reading it in parallel, you are actually decreasing the total time it takes to read that data. As we saw in that other example of where we were reading 1 TB data from multiple machines. Is that clear, Sandeep? Yes, Sandeep. Gaurav, don't worry about data replication. I will cover that very soon. Okay. Yes, we are gaining the throughput. Right. Right, divide the data and get throughput, right? But it's not all that simple, but there are a lot of complexities involved, and we'll look at that. Now, Gaurav has asked me a question. Replication causes data redundancy, then why is that pursued? Okay, so the question is that, I said, right, to make it highly fault tolerant, we replicate the data in multiple places. So yes, it causes data redundancy, and it is pursued because these computers, as I told you, are commodity hardware. The places where we store data are commodity hardware. They're not high quality, high availability machines. So there's a good chance that they'll keep on failing in between. You can, I mean, the Hadoop cluster can use your and my machine as well. Okay, you don't need high quality hardware there. So that is why we do it, to make it high availability, we replicate the data in multiple places. And we will look at that once again as we move forward. Okay, is that fine, Gaurav? Is that okay to everyone? That why do we use data replication? Quickly, can you give me a smiley if it is clear? Great. Okay, great. Thank you, guys. Thank you very much. So, and as I told you, it is suitable for large data sets. Okay, so it's not suitable for applications which have small files. Okay, so even so basically, since a lot of information is stored as metadata on the name node, I'll not get into more into it. It makes a lot of sense if we are storing this data, storing large amounts of data and not small large amount of files. Instead of using large amount of files storing small amount of data, it makes more sense when we have large sizes of files and less number of files. Is that clear? If the data set is large, then it makes more sense, HDFS. Okay, each file is huge. Okay, right, and you'll understand this very soon. Okay, so Anand is asking me to repeat. Anand, I was saying HDFS is more suitable for cases where you have huge amount of data in a single file as compared to small amount of data spread across multiple files. Okay, is that clear? And the next point is streaming access to file system data, which means that it should have streaming access to file system data. Means that if we are doing something like a write once and read many times kind of operation, which will be the case when we are analyzing logs. Okay, so unstructured data, this will be the case. You will be doing streaming access to data where you will not be updating the records again and again. That's very much different from a bank record. So that is where this makes more sense, where you write once and read many times. Okay, and HDFS can be built out of commodity hardware, which means without using any high-end servers, you can build the high-end storage devices. You can build HDFS. Is that fine with everyone? Are all these points clear to everyone? If nothing is clear, please ask me. It's important. Okay. And otherwise, please give me a yes, or I'll just move ahead. Okay. Thank you, guys. Thank you. Commodity includes, yes. Yes, it does. It does include RAM. Because it has to run a few things there. We'll talk about that. Okay. So, Anand is asking me a question. Does commodity hardware include RAM as well? Yes, Anand, it does. It does include RAM as well, and the reason why it needs RAM, because there will be some services which will be running on it. The task tracker which we talked about is something which runs on the commodity hardware itself. Okay, we'll know more about it. Okay, Samir is asking streaming access, please explain again. So Samir, in cases where you're writing once and reading the data in one shot, where reading the complete amount of data is more important, the time taken to read the complete data is more important than the time to actually fetch a single record from the data. That is what streaming access is. Okay, like a YouTube video, if you want to, it's not important that you seek a particular point in that video. More important is how soon can you get the complete video buffered. Okay, so and similarly the Facebook logs, you don't need to look at a particular what a person liked in that. Okay, you need to analyze the complete data together. So that is where you write once and read out multiple times is what streaming access is. Is that clear to everyone? Is that clear, Samir? Okay, great. So let's move on. I've written one more definition. I promised, but I broke my promise. I'll keep breaking my promises. So okay, so HDFS is a file system designed for storing very large files. One, very important, with streaming data access patterns. That's also very important. And it runs on commodity hardware. So these are the two. Okay, Anand Kumara says promise is always to break. Thank you, Anand. Thank you for supporting me in this. Okay, so basically 3 important points here: very large files, uh, streaming data access, and commodity hardware. These are the 3 salient points which you have to look at when you design a Hadoop distributed file system. Okay, if you have to take a decision whether you should move to Hadoop or not, these are the things which you should look at. So people from the architecture kind of background, or who are business analysts, if they have to talk to their clients, these are important things. When the client asks them, why not we also move to big data and Hadoop, you have to answer, you have to look at these points. Is that clear to everyone? I believe Devashish was from that background, right, Devashish? So you might have to answer such questions. So files should be in terabytes. Okay, great. The file should be in terabytes. Okay, great. So Anupam, you had given me your introduction, which I missed. I believe you are an architect. Is that correct, Anupam? Can you quickly tell me yes or no? Okay. Yeah. So people, no. I'm sorry, Anupam. Can you please introduce me to yourself once again? What do you do? Okay, I'll while you write, I'll explain. So people who are going to take these decisions in their organizations, or are going to talk to clients on these, where a lot of clients, because of the hype around Hadoop, they will be asking why we should also move to big data. Okay, okay. You are a ETL developer. Okay, great. So, okay. So you work with TCS with 6 years of experience. Great. So yeah, for you probably Pig and Hive will make more sense, which is fine. And yeah, so basically for people who are into this decision making, whether we should move to Hadoop or not, whether we are ready to take this big data, these are the things which you should look at. Okay, is that fine? Rohit is a solution architect, and Rohit says, I'm a solution architect, and these definitions will really help me as I have to read between lines and explain our customers. So you keep breaking your promises. Yes. Thank you, Rohit. That I could actually help you in talking to your customers. Thank you very much. So yeah, very important point, very important definition. Some definitions I'll keep here, and unless and until I believe that definitions are not important, I'll not keep them. But in this case, it's very important. Okay. So even if you're not a solution architect, even if you're a developer, it is very important to understand the bigger picture. Okay, and otherwise you will just be doing some what I should say, bull's job, not donkey's job. Okay. Okay, so let's move ahead. Can I get a quick smiley from everyone if you guys want me to move ahead? Okay, and then I'll tell you where HDFS is not a good fit today. Again, Rohit, Mohan, please pay attention here. Ajay, all the people who are looking at telling people to implement Hadoop, please make sure that, okay, yes, thanks Anand. Anand, okay, so where you have low latency data access, which means that you have to quickly read a record for a bank kind of transaction kind of thing, please don't move to HDFS even if you have huge amount of data. Okay, fine. Lots of small files again, because the file information is stored in as metadata, and if you are, yeah, I'm telling you that, Sandeep. Just give me 1 second. Okay, because if you store these, see, Sandeep is asking me why. Okay, and I'll answer this question as before we move on out of this. Okay, and when I say where HDFS is not a good fit, I also add something called today. So going forward, Hadoop is working on it. It might become possible to do all these things also as efficiently as a traditional database can do. But as of today, Hadoop is used for reading out huge data sets in one single shot. Okay, if you want to seek a record from a file, this probably is not the best way of doing it. Okay, because you will not know where a single record is kept. The information is kept at a very, very high level in terms of blocks, and data is usually unstructured. There are no tables and columns. The data is stored as multiple logs. Okay, and if you have a lot of small files, then also this doesn't make sense, because for each file you will have to store a metadata, which will make things very difficult to seek whenever you want to. Is that clear? Is that clear to everyone? Okay, and the most important point is that if you're writing data multiple times and if you're doing arbitrary file modifications, HDFS is not a good fit. Okay, which means that if you're updating the data again and again, the same row, same column again and again, then HDFS is not the right place to do it. A traditional RDMS works better. Okay, so see, Rohit is asking me a question. If not Hadoop, then which tool is a good fit today? Any recommendations? So guys from the Teradata and Oracle background, can you boast about that now? Can Syed answer that? Sandeep, just give me a second. Syed, would you like to answer that question? Yes, RDBMS will be used for this, right? So Sandeep, the question is low latency data access means that if you have to quickly seek one particular data from a file, okay, then this is not the best thing. Hadoop is better when you have to reach the complete file in one shot and then do analysis over it later on. Okay. Okay. Now there are frameworks which are available on top of Hadoop. As Pig actually is something which can do some SQL-like operations. Hive is the place where you will be doing a lot of analytics there. We will talk about those as we move forward in the course. Okay, fine. So Sandeep, is your question answered? See, I'll not get into details of any of these things right now because not everyone would be interested in it right now, number one, and not everyone will be able to understand it also. So please be patient with me, and some answers I'll give you later on. Okay. As we move, I mean, I can ensure if you attend all the 8 classes, you will understand everything. But today also you will understand HDFS. So can I move forward, guys? If this is clear to everyone? Okay, I am getting a lot of yeses. Great. So now we talked about name nodes and data nodes. Now it's time to remember what I told you in that slide where I told you just remember something. Okay. So there was something associated with a name node. Can you quickly answer that on the chat window? What was associated with a name node? I'm getting some answers. Okay. 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 Sandeep, I did not tell you that. Okay. So everyone has given me the answer, which is job tracker. Okay. Yes. So job tracker is the thing which is associated with name node. Okay. Yeah. And data nodes, what was that with data nodes? Task tracker. Correct, correct, correct. So basically there are two major components of HDFS. One is the name node and the other one is the data node. Name node is the master node, okay, on which the job tracker runs. Okay, job tracker is a daemon, right, which runs on the name node, and data node is again that commodity hardware on which another daemon called task tracker runs. Okay, so now I'm introducing these two terms in slightly more technical language, but going forward in the next couple of slides we'll understand more details about it. Okay, is that fine with everyone? So major components on HDFS is name nodes and task tracker and job tracker and data node and task tracker. Okay. Okay, Samir is asking what is a daemon. Can anyone answer that question? What is a daemon quickly? Okay, Rahul wants to answer that question. Rahul is with me. Rahul, you want to answer that question?
Hi everyone, this is Rahul. Samir, to answer your question, what is a daemon? Yes, it's basically a process or a service that runs in background. It's very well said, Mohan. It's a resident program. It's a resident program, and it is a service that runs in the background. You can call it a process also. Okay, so that is what a daemon is, and is used in the Unix environment. This terminology is used in the Unix environment in general. Does that answer your question, Sami? Mohan says the equivalent in Windows is a service. Yes, Mohan, it is a service in Windows. And in DOS is a TSR. Yes, definitely. That's a definite yes. It's a TSR. So I'm handing it over to Abhishek now again.
Yeah, so thanks Mohan for the insight. So Mohan has told us more about daemon. So Mohan says that yes, they run in background, Samir. Yeah. So Mohan has given us some very good information. Mohan tells us in Windows, the equivalent of a daemon is a service, and in DOS it's called TSR. Okay. So can we move ahead, guys? Okay. Yes, Samir. Yes. Okay. Guys, I'm really sorry I grabbed a couple of chips in between while I handed over the mic to Rahul. So if you're hearing some crunching noise, I'm really sorry for that. So Mohan is okay. Mohan has given me one more thing. Mohan is saying I am proud that I am would be the only ex-DOS programmer here. I am the only one. There won't be anyone. Okay, there won't be anyone else who is a DOS programmer. Anyone else who is a DOS programmer here? Mohan, I have done something in school. Okay, but I'm sure I've not done anything as much as you would have done in your days. So Mohan is an ex-DOS programmer, and is there anyone else who has done programming in DOS? Syed Munawwar is again saying I have done it. So Mohan, you're not alone in school. Okay. Hey Mohan, thank you very much. Mohan says I have written the first version of Norton antivirus in DOS and Windows. So Mohan, really, really great to have you here. I'm sure we'll learn a lot from you, sir. So Mohan is the guy who has authored the first version of Norton antivirus in DOS and Windows. Great to hear that. Can everyone give me a smiley or a clap for that, guys? Wow, Syed says wow. Great clap, says Gaurav. Awesome, Mohan, says Rohit Malik. Okay, with claps, Yashwant. Ajay has given smile. A big applause from Anupam. Mohan rocks, says Rahul Tiwari. Clap for Mohan Anand Kumaran. Okay, great, guys. So thank you very much, everyone, for appreciating Mohan's effort on antivirus. Otherwise, we would be right now. Maybe some virus would have been injected in this system itself, and we would be. We would have gone for a toss. I could not crack a joke here. I'm really sorry, guys. Not every time I'll be able to do that. Okay. Mohan says it's ancient. Mohan, you're young. Okay. So main components of HDFS. Okay. Now we have. I've put a picture here. Can everyone identify with this one? And can anyone tell me if anyone has ridden this vehicle anytime? Mohan, I'm sure you must have been. You looks like you must be having really deep pockets with all those authoring, and you've exited from your company as well. Okay, so everyone this is their dream car. Mohan, have you ever taken a ride in this one? Oh, Rahul Tiwari has taken it. Great, Rahul. Where did you get a chance to do that? This car, Mohan, can you identify this one? Samir has also done it. Samir, Sweden. Okay, great. So this is a Lamborghini. Okay. Sandeep tells me I also have taken this in dream. So with whom did you dream this, Samir? So sorry, Sandeep. Katrina Kaif? Oh yeah, tasks were covering, but okay. Sandeep says my wife. Okay. Okay. Sure, Sandeep. In your dreams, okay, that's really good, man. Really loyal husband. Your wife will be happy to hear that in your dreams you dream about her, and that too in a Lamborghini. Okay, so Mohan, did you take a ride in this one? Okay, Gaurav says Sandeep is a liar. So it's getting great here. We have got a great environment here. Okay, Mohan says not wealthy enough. Okay. Okay. So Gaurav says Sandeep is a liar. Okay. I kind of agree with Sandeep, with Gaurav or with Sandeep, I don't know. And Samir is giving me a smiley. Okay. So now the reason, let's get a little serious here. The reason I put it here is that this is the name node, and the idea behind putting this car here is that you need to understand that we have to put a very, very reliable hardware here. Double, triple redundancy hardware, okay, high reliability machine. You might end up putting a RAID here, okay. So name node is the master of the system. It maintains and manages the blocks which are present on the data node. Okay, please note that it doesn't store any data. It maintains and manages the blocks which are present on data nodes. So it is the data nodes which actually keep the data, okay. Is that clear to everyone? And the reason why I put a Lamborghini here, it will be a very, very expensive hardware, and it will have a double and triple redundancy there. Okay, is that clear? Okay, now can anyone identify this picture? Sandeep, have you taken a ride in this one in your dreams? Kolkata taxis. No, Sandeep doesn't dream about ambassador. Okay, so these are ambassadors, our politicians and all our government officials take rides in this, not in this colored one. Gaurav says reality check. Okay, yeah. So Anand Kumaran says old taxis in Mumbai. Yes, Anand, I don't know if you said Mumbai. I just added Mumbai. Oh, so Vidyasagar told me, oh boy, I thought you would go with the Nano. Okay, Sayyid tells me still in Kolkata, these are the taxis which are run. No, I actually Ambassador is much more expensive than a Nano, but I still would like to take this analogy to tell you why I said commodity hardware. Okay, so a name node is like a Lamborghini and the data nodes are like ambassadors. Okay, did you like this analogy? Do you want to praise me on this? Okay, so don't praise me. It was put by Hisham, who is the guy who is in the support team. I just take the credit. But
welcome to GoToWebinar, web events made easy.
guys, are you able to hear me now? Okay, I'm really sorry. What happened was that I got so excited that I pulled the microphone out of the computer. I'm really sorry about that. Okay, so yeah, I was telling you about that. It was Hisham who actually did this. I'm sorry for the interruption, but yeah, it was Hisham actually who put this analogy, and the reason I'm calling this name again and again is because he's the guy who leads the support team here. And for any queries on which you might have on any practical issues 24/7, he is the guy to catch. Okay, so he and his team will be supporting you, and these guys are experts in this course in Hadoop, and they'll be able to help you with any problem you face. So feel free to reach out to Hisham after this class for any questions. Okay, is that fine? Is that okay? Everyone is able to hear me, guys? Now back. Am I back with you? I did not get any response. Okay, great. So sorry for that. Okay. Now data nodes are, we say, when we talk about data nodes, these are slaves, as I said earlier, deployed on each machine and provide actually the actual storage happens on data nodes and not on name nodes. Okay. And these are responsible for serving read and write requests for the clients. Okay. So the read and write actually directly happen from data node. Now don't worry about that. I've just said something. That read and write happen directly from the client. I'll explain that in detail as we move forward. Okay, just keep this thought in your mind. Okay, is that fine, guys? Can I move ahead? Yes, Mohan. The task tracker runs on each data node. Okay, great. We'll understand all this. I'll ask you questions in the end of the class, and I'm sure all of you will be able to answer that. Okay, Sandeep is asking me a question. If data node increases, then do we need to upgrade name node? Sandeep, at the beginning of when we define the system, we see that, okay, till what level do you want to scale up your cluster? Based on that, we choose a name node. Most of the times, yes, you do not have to upgrade your name node if you increase the number of data nodes, because name node does not store much information. It is just RAM, and it stores mostly the metadata. I'll make you understand more about this. Anand is asking me a question which is an interesting one. He says 2 servers are required for name node, data node. Well, ideally in the real world, there will be a name node which will be on a high availability software hard machine like a Lamborghini, and data node will be like ambassadors. But if you want to try out something, then a same machine can be used to create one data node and one name node. Okay, it can run on the same machine. Okay, now Mohan has asked me a question, is the name node also commodity? No, Mohan, that was the whole point in actually putting this Lamborghini picture here. Name node has to be a double, triple redundant machine, which can be even a RAID. Okay, so it cannot be a commodity hardware. because this is the single point of failure in the system. And when I say as single point of failure, I'll explain it. So don't worry about it right now. Okay, we'll understand. Mohan, does that answer your question? Can I move ahead? Okay, great. Data node can be redundant. Okay, now let's go a little deep. Mohan, we'll answer these questions as we move ahead. Okay, is that fine? Okay, as we move ahead, we see we've introduced a new term here. Can everyone look at this diagram for 10 seconds, take a deep breath, and think about what? Sandeep can think about his wife, and I'll think about Katrina Kaif. Okay, and look at this, and client, job tracker, task tracker, map, reduce. What is the new term here? A client, right? Anything else which you see as a new term on this slide? Do you understand everything else other than the client? Everything else we've covered? Okay. Map reduce, yes. We've talked about map reduce earlier as well. We've said map reduce is a programming model to retrieve and analyze data. Only this much has to be understood today. Okay. It's a simple programming model. Okay, is that fine? So other than the client, everything else is clear to everyone? Okay, cool. So client is actually client is an application which you will use to. I'm giving the answer. A client is an application which you use to interact with both the name node and the data node. Okay, which means to interact with job tracker and task tracker. Is that fine? Is that fine? As a very simplistic definition, a client is an application which will be running on your machine, which you will use to interact or give commands or look at the statuses from a job tracker or a task tracker. Is that correct? Is that okay? So interaction between the user and the name node and data node is done through a client. Okay, and it is called the HDFS client. Is that fine, everyone? Can you quickly give me a smiley on this? Or else I'll move ahead. Okay, cool. Okay, let's get. Okay, Sandeep is asking me a question which I'll answer. Sandeep will get an answer. Don't worry. Okay, Devashish, client is a application or a software which will run on your machine. Okay, we will see an example. We'll show you how a client looks like by the end of this. Okay, client is an application which runs on your machine. Okay, which you will use to interact with data node or a name node, which in turn means the job tracker or a task tracker. Okay, we will all your questions will be answered, Anand, and Sandeep, your question will also be answered. Don't worry. Just keep that in your mind. Just keep these questions in your mind. All these questions will be answered. Okay. So let me just Rohit, I'll answer your question as well. Just give me 1 second. Okay. Now let's look at this diagram. This is a little more complex than the earlier diagrams. A few more new terms are also introduced in this. Okay. And I'm going to explain this. Don't worry, you will by the end of this slide you will understand each and every term here. Okay. So we have a name node here which is clear to everyone. We have a client also which we've understood. We've understood that as well. And now there is something called a rack. Can anyone explain me what a rack is? A lot of people will be knowing that. Is there anyone who doesn't know what a rack is? Okay, Sandeep tells me it holds hard disks, right? Gaurav asked me to tell you. Okay. Ajay is asking me what a rack is. Okay. Can anyone give me a... Okay. Anand is telling me rack is a storage area, which is right. Can anyone else add to that? Devashish tells me a storage mechanism. Can anyone else add to that? Okay. Okay, there are more people. Okay, so yes, we have some answers here. Samir Mahapatra tells us that it is a group of nodes. Yes, it is, that's right. Data stores in clusters, in a cluster, right? Yes, Gaurav, collection of data nodes in a cluster is So a rack is I believe Syed will be the best person to answer this question. Syed, can you answer this question quickly? Can you give me an answer and tell me if you are with me? Looks, sorry. Okay. So basically rack is a storage area where you will have multiple data nodes put together. Physically, we said that all these data nodes can be physically at different places, right? You remember the first diagram when we showed you 4 different machines at different physical locations? Do you remember that? And then we created a DFS out of it. So basically a rack is a physical collection of data nodes, okay, which are stored at a single location. Okay, so basically there can be data nodes stored in Bangalore, there can be data nodes stored in Kolkata, there can be data nodes stored in Australia. Together we can have a set of data nodes can be stored in a physical location in a rack. There can be multiple racks also in a single location. So it doesn't mean that if it is stored in a single physical location, it will be stored in a single area. Is that clear to everyone now? Rack is just like a rack. You have a rack of shoes, right? Where you store all your shoes. Similarly, we have a rack of storage devices. Is that clear to everyone? Can I quickly get a smiley here from everyone who said no then? Okay, cool. Everyone has understood that. Great. Then, so what we're showing here is, Ajay, thank you very much. So what we're showing here is that we have a name node. We have a client which interacts with the name node. And Rohit, I'll quickly answer your question here. Rohit had asked me what is the mode of communication. Is it HTTP? No, it is SSH. Okay, we'll answer. Rohit, is that clear now? So Rohit had asked me a question that how does client interact with name node or data node? Is it through HTTP? So Rohit, it is through SSH. Okay, and for everyone else also, this is the answer. Now we also see a term called replication here. Okay, so as I told you earlier, data is always to maintain the fault tolerance on a Hadoop system. Okay. To maintain fault tolerance on a Hadoop system, we replicate data. We maintain multiple copies of the same data on multiple data nodes. We'll understand how it is done. In very clearly, we'll understand minimum number of replicas should be 3. That is the minimum number of replicas required by SDFS. Okay, and it can be defined by the user. Okay, so basically when you write a data on a SDFS, you replicate it in at least 3 data nodes. Is that clear? Okay, is that clear to everyone? Okay, great. Then there is something called block ops. Okay, so basically the operations are performed in terms of blocks. Okay, now the block size Rahul, you have to, Hadoop advises you to at least, Rahul is asking, is it compulsory if I didn't want? See, as I told you, right, we use commodity hardware here and we still don't want to lose data, and there is a good chance that some of these machines will keep on failing. So we need to keep data in multiple places. Okay, the redundancy has to be maintained, replication has to be done. Okay, okay, is that fine, Rahul? Okay, now, okay, now the other thing which I was telling you was that the block size in HDFS is, can someone tell me other than Mohan what is the block size in Unix? Can someone tell me that? What one quantum of block, how big is that? No one knows about it? No one has answered that question. I'll let Mohan answer that. Mohan, can you please tell me? What is the block size in Unix or a Linux machine? Guys, you can do Google as well. I'm not your teacher. I'll not stop you from doing Google. Please Google things which you do not understand in the class, which you want to ask actually. Okay. Okay, no problem. And can you guys Google? Don't think that I am the only source of information. You can also be the source of information. Google is the biggest source of information. I have also learned everything from Google. Can someone give me that answer quickly? Rahul Tiwari, where are you, man? And where is our friend Devashish? I have not heard from a couple of guys for a long time. I want them to answer now. I haven't heard from Dinesh. I am asking the default size. So Ajay is giving me an answer 8192 bytes. Pawan, you've not answered anything, friend. Can you quickly Google this and give me an answer? You can keep this answer for yourself. I'll tell you. Okay, so we've got a lot of people giving me the right answer. Okay, so now the block size in HDFS is 64 MB. Okay, it's 64 MB, and the default block size in Linux is 8192 bytes. Okay, so basically HDFS is built over Unix, and HDFS, as I told you earlier also, is used to store huge amount of data, the single block of operation. And I'm asking about the default size. It can be configured to a bigger size. The minimum is 64 MB. Okay, does that make sense? And this clearly tells me if you have smaller file sizes, there will be a lot of metadata which you'll have to store, and it will not be a very useful system to use. Is that clear to everyone? Usually it will be much more than 64 MB. We'll be configuring it in a few GBs or maybe sometime TBs. Is that fine? Does this answer that question which everyone had, that why can't we store many small files in HDFS? Is that okay, guys? Okay, good. So everyone has understood that. I've got a few yeses. I did not get a response from Pawan. Pawan, can you quickly answer this if you have understood this? Thank you, Pawan. Thank you very much. I think you were out for lunch for some time. Is that correct? Or you were here? You were attending everything. Guys, I'll be asking questions in the end, and everyone will have to score 100 on 100. Okay, 10 on 10. So please pay attention. Now, okay, so we've understood most of these things here. Now I'll just explain this diagram once again. So we have a client which interacts with a name node. It also interacts with the data nodes. Okay, the client does a read and write. There's something called metadata here. So can anyone tell me what is the metadata? Quickly, can someone tell me what is the metadata? Okay, so a lot of people have told me the right answer. It is a configuration data about data into data. Yes, that's true. So metadata is not the actual data, the actual logs which will be storing, but the data about data, which means where are these. If I'm storing a block, name node will have this information that where is this block where is this data getting stored. Okay, that information, which are the name nodes, where are the racks there, on which rack which data node is there. All this information, block map is what, yes, exactly. So a block map is what Mohan has told me. This is exactly correct. So all this is metadata, and all this data is stored in the name node. Name node, this data is stored in the RAM. Please remember this. It's stored in the RAM. I'll tell you more about it, but for now, let's understand that it's stored in the RAM to have fast access. Okay, and actual data is stored in the data nodes. Okay, so is that clear to everyone? We will go into more details of these operations, read and write, as we move ahead. But for now, does everyone understand what a name node is, what metadata is, what replication is, why do we need replication, what data nodes is, what a client is, what a rack is? All these, if the answer to all these questions is yes, please quickly give me a smiley. If you don't understand anything, please put that name there. I'll explain it again. Looks like everyone has understood. I'm doing a great job. Okay, Samir is asking me what about block operations. Samir, I'll answer that going forward. Okay, don't worry. So each time name node create metadata when we are on cluster. Sandeep, can you rephrase your question? So name node is a high availability machine, a Lamborghini, which will be stored anywhere. It should have good protection. Yes, it will be, okay. So Sandeep has a question. Yes, all this metadata is stored in a RAM. There's something called a secondary name node, and I am introducing a new term here, so please pay attention. There's something called a secondary name node, which is used to, which periodically reads the data from the RAM of the name node and persists that data into a hard disk. So name node does not write it into a hard disk. Name node keeps that data in the RAM. It does not spend time or operations or cycles in writing into the hard disk. There's something called a secondary name node which keeps on reading from the name node, okay, data from the RAM of the name node and writes into the hard disk. Okay, is that clear to everyone? But secondary name node is not a substitute of a name node. Okay, so if the name node fails, the system goes down, and that is the case in Gen 1 Hadoop. I'll tell you what happens in the Gen 2 Hadoop, but for now, let's try to understand that name node has a single point of failure. There's no backup name node, which though it is called a secondary name node, it does not become an active name node if the name node goes down. It just reads the data from the metadata from the RAM of the name node periodically and keeps on writing into a file system. Is that clear to everyone? It does not come into picture if it keeps a backup of metadata. Okay, so it does not if the name node fails, it does not become the name node. Is that fine? So in Gen 1 Hadoop, when we talk about Gen 1 Hadoop, there is just a single point of failure, which is name node. If the name node fails, the system crashes. Okay, and to get the system back, you'll have to put another name node and read the data back from the secondary name node, and you cannot retrieve the data from the time the last backup was taken. Is that fine to everyone? That is why we need a Lamborghini for a name node. Does that make sense to everyone? Is there anything which is not clear here, guys? Okay, good. So everyone has understood why we needed a Lamborghini there? Because we do not have any backup to it. Sandeep, just give me some time. I'll explain everything. I'll explain everything. Okay, just give me some time. All these things are going to be covered in the next slides. Okay, yeah. So basically, the important thing to understand here is that the name node stores all the data in its RAM. There is a secondary name node which keeps on reading this data from the RAM and keeps on writing into a file system. It is not a data node, it's a separate file system where it keeps on writing, Rahul. Okay, so to make sure that we are storing what was happening in the RAM, and it keeps on syncing that data time and again with what is there in the RAM of the name node. Is that clear to everyone, guys? Very important concept. And if you guys are preparing for an interview, someone can ask you what happens if the name node crashes. Does the secondary name node take over? The answer to that is what? Yes or no? Very good. Everyone will crack that interview for Hadoop. Shri Vidyasagar tells me definitely not. Rahul, you will move from Teradata to Hadoop, man. Okay, so that's a very important thing. Now, okay, now the second thing which is very important is, and I'll take a liberty to introduce that as well. I talked about Gen 1 Hadoop. So now there was this problem with Gen 1 Hadoop that we had just a single point of failure, and the secondary name node was a misnomer. It's actually a misnomer. It looks like that the secondary name node, and it's actually used to fool people in interviews. Okay, so it's a misnomer. In Gen 2 Hadoop, now someone can ask you this question as well. Now, what is the difference between Gen 1 and Gen 2 Hadoop in terms of name node? So in Gen 2 Hadoop, we have an active passive kind of name node structure where there are two name nodes. One is the active one. There is a second one which is passive one. Very important to understand. Pawan, are you getting this point, sir? Anyone preparing for interviews? I was told that Pawan is preparing for some interview. So it's very important to understand this. So in a Gen 2 Hadoop, we have okay, great. Sure, Rohit. Okay, so in Gen 2 Hadoop, we have an active passive kind of a structure where there is an active name node and a passive name node. So in that case, if the active name node goes for a toss, the passive name node can take care. So that is the difference between Gen 1 and Gen 2 Hadoop. Is that clear to everyone, guys? I'll ask these questions in the next class as well. So you have to remember this. Okay, good. Yeah, it's a standby kind of thing. Right? Yeah, right, Rahul. Okay, Ajay says, okay, can everyone give me a smiley if you liked this idea? If you really liked this, good. So there will be a secondary name node which will keep on doing a backup data. Okay, but active name nodes will just store data on the RAM. Okay, Sandeep? Name nodes will not waste their cycles. Yes, name nodes will not waste their cycles in writing data to the file system. Okay, name node are high availability machines. They are very fast, very, very expensive. We will not use a Lamborghini to drop you to the mall. Okay, is that fine, or to pick you from the railway station? Okay, let the secondary name node do that. Is that fine? Rahul, we'll talk about it later on here. Don't worry. Okay. Yes, there is a secondary name node in J2 Hadoop as well. It will be there because we have to store all this data persistently. We have to persist all this data in the hard disk. Okay. So let's move forward, guys, if everything is clear here. Now some questions can be answered offline as well. Okay. 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 So now we'll get into a little more details, and we will look at how does a job tracker and a task tracker work. Okay. So you can have a look at this diagram, and we will surely explain it one by one. Okay. So Rahul wants to explain this. Rahul, you want to explain this? Okay, great. So I'll let Rahul explain this while I also grab a cup of coffee. Okay, and I'll be back in 5-10 minutes. Is that fine? Can you say a welcome to Rahul, guys? Quickly, can you give me a smiley for Rahul? Okay, welcome Rahul. Hi Rahul, a lot of people are welcoming you. So Rahul is an expert in Hadoop. He has been working with me in my team, and both of us work together. He's a real hardcore technical guy. Okay, a lot of questions I'll not be able to answer. He'll tell me you are giving a wrong answer, but he keeps correcting me. So he's your hardcore techie in front of you. I'll give it to Rahul now. Okay? Yeah, Rahul, please go ahead.
Hi everyone. Very good afternoon to you all. So I believe I am audible. Okay. So give me a moment. I'm actually unwinding the cable of my microphone. It's pretty stuck in the chair somehow. Okay. So just give me one moment for that, and then we'll be done.
Welcome to GoToWebinar, Web Events Made Easy.
Hi guys. So am I audible now? Okay, so a very good afternoon to you all. Let us continue with the discussion where Abhishek left. Okay, so I hope he gave my brief introduction about me. Okay, so I'll give you some 20 seconds of time to go through this picture. Okay, and remember it has mentioned some steps, something like copy input file, submit job, get input files info, then again there is one more submit job, there is create splits, there is some upload job information, some job.xml, job.jar is there, some input files is there. Okay, so just I'm giving you 20 seconds of time. Just go through this diagram so that once I start explaining it, you are clear about the steps we are talking about. Okay, here we go. A user in this diagram, there is a client in this diagram. Let me be very clear about this picture, because there is always a confusion: who's the user, who's the client, and where is this job tracker, where is this DFS. First of all, when you work on a Hadoop environment, when you work on a clustered environment, okay, the entire HDFS, the Hadoop distributed file system, behaves as one file system, though it is spread across over all the data nodes. That is one of the features of a distributed file system. Okay, a user is, who is a user? It's a person like you and me who has some query, who needs some kind of information, who wants to get some kind of a data, is a user. Okay, client could be the name node machine or a job tracker machine. Okay, initial you can understand it as a name node machine, but the real handling of things is done by the job tracker. The reason why I'm talking in that a name node and job tracker separately is because in a practical environment, when you are into a production environment, name node is one separate host, a job tracker is run on another separate host. They are not run on the same machine. Okay, production environment, we have such kind of a configuration, and then there are data nodes. Okay, so that's about user, that is about client, and then we have DFS. DFS is the file system. So it says a user copies some input file. Remember we talked about write once, read many times. That is the behavior of Hadoop. Okay, so a user is copying some files, any file, it could be anything. Okay, then you have something called as user submitting the job. User has some query. He has already copied those files, maybe some kind of a log or some kind of information is copied on the DFS, submits a job, some kind of analysis is to be done, and some data is to be fetched out. Then what is there? The client tries to get the information from the DFS, where the files are located, which rack, which data blocks, and blah blah informations that we have about the file. And this is what the metadata is all about. Metadata on the name node has all these information, and for a particular data block or for a particular file where exactly it is stored, this information is supplied by the name node. Then there is something listed out as create splits. Create splits is nothing but when a job is submitted. The job may be a big job. Okay, we are talking about a bigger processing of data that could be broken down into smaller jobs. Think about it in such a way that you have a big program, a big script, or a big program that has some smaller functions to it. Okay, now what happens is, or suppose there is a way to break down the entire function, entire program into those smaller functions. Those smaller functions are to work, generate something, okay, and then provide you the data in some manner. We'll see how exactly this goes on. Okay, so that is what the create split is. The bigger job is split into smaller job based on some kind of a logic, some kind of algorithm is there for that. Okay, so it is broken down into smaller jobs. Those job information is uploaded, okay, by the job tracker. The communication you can see, the client and the job tracker, you can assume it, or you can understand it in such a way that there is a socket communication kind of a thing between the user, the name node, the job tracker, and the job tracker and the task tracker. So this is one entire session that is being established where user is submitting a job, it goes to the node name. Okay, I'll do that. Okay, so here is the user. Okay, so for suppose there is a socket that exists between this, okay, a user submitting a job, okay, the job is being split and all those stuff. The information is being uploaded to the DFS is about this job.xml, job.jar. There are two files basically which contains the information about job. We will see later on down the line what exactly information is contained into these files and what they are all about. Okay, but for this point of time, let us understand that this particular part is there. Some kind of information is uploaded on the DFS somewhere. Okay, and then that particular job list, this particular thing, job queue, this is this enters a job queue basically, which is at the job tracker point. Okay, so the client then submits this particular job. We will see what happens exactly after this in the next slide. But are these points clear to you? All these steps listed out over here. Please let me know if you have any questions. Okay, Gaurav says yeah. I'll take that as a yes from each one of you that this particular slide is clear. Come on, some quick yes, some more quick yes. We can really proceed to the next slide then. Okay, Ajay says yes, Rohit says yes, Rahul says yes, Devashish says yes, Pawan says yes. Okay, Syed also says yes, Vidyasagar gives me a yes. Okay, so we'll proceed to the next slide then. So over here, have a look. The entire part of the last slide we have listed out over here in the smaller section where client submitting a job to a job tracker. Okay. Now, this job basically requires some files, and those files are present on the DFS whose information was supplied by the name node. Okay. So, this job tracker tries to get where are all the blocks located of that particular file which is to be processed. Now, one important concept over here, a kind of a difference between traditional RDBMS and Hadoop. Okay, this is important. Pay attention to it. Okay, there is a difference between how the Hadoop works and how the traditional DFS worked. In traditional DFS environment, I'll not go into too much of detail. There was a solution that the data would be present on different nodes. There was one master node kind of a configuration, and when the data was to be processed, the data was pulled out from that particular machine, was taken out onto that particular master node and then processed. Okay, now think about some TBs of data or some even hundreds and thousands of GBs of data if you really want to think of. Think about this situation where you have to transfer such an amount of data onto the network. How much time it's going to consume? How much network bandwidth will it consume? Hadoop, the difference, it does what? It prefers data localization. Okay, what I mean by that is, you see maps and reduce, they are basically programs. Okay, so what it does, instead of calling data to the master, it sends out the small KB size program to the data node, processes the data over there and then gets you the output. Think how much time will it save? TBs of data on the network and KB of data on the network. It's so easy to process in such a way, and that is the beauty of Hadoop, and that is why it is listed as one of the most powerful processing engines today. Maybe something in future something else comes up, but for today it's one of the most powerful processing engines, and Hadoop ecosystem has integrated too many things into it to add to the beauty. Okay, so you see something listed out over here as a job queue. Let us understand this, that in this particular job queue, one by one things are taken up. Okay, it has all those jobs that were created out of the splits. Okay, and one by one those jobs will be served. So what exactly is happening now is, this particular job is picked up, which is green in color. Okay, this particular job is picked up. Okay, then the job tracker creates maps and reduces. These are the programs that are will be sent to the data node for the processing. Okay, now from DFS it has the information, okay, where exactly this is stored. Okay, now there is something named as input split. I'll give you an explanation on this. And these maps and reduces are sent across to the data nodes. Now what is an input split? Input split is basically the file, okay, the bigger file which is broken down into the chunks. There is one parameter called as input split, which we can define what will be the input split based on which the file is really divided. It's a configurable parameter. Okay, and for that input split there will be as many maps created as the number of input splits. If you have some 40 input splits, you have 40 maps for that, and based on that the reducers will be there. Basically how exactly this map and reduce works is, map processes the data first, it generates a kind of a key value pair, on that particular key value pair the reducers work to produce you and to give you a final output. Okay, there are some things called as sorters, shufflers, combiners, which are in between these two, but the most important part is this map and reduce. Those sorting, shuffling, combining and things go on based on our need, how we really design, how we really write our own map reduce programs. So is this slide clear to you all? Any questions? Can I have a quick yes, a smiley? Rahul has a question. So these maps and reduces are written based on business logic. It's not only a business logic, it's a requirement based, what you really need to process. And the logic could be anyone's logic. It's I would not say that it's only a business logic. It could be a developer's logic. It could be the requirement logic or anything. Okay. Gaurav is asking, please tell about map and reduce definition once more. Okay. Maps and reduce are the heart of Hadoop system. Okay. Maps and reduces are nothing but a program written in language of your choice. It could be Java and is best suited for Java, but it could be Python, it could be Perl, it could be any other language, C, C++. You could write in that also. There is something concept as called as Hadoop streaming that's there in for Perl. There are some modules for that. The same way it goes for C++. So it could be any language of your choice into which you can write and it will work. Okay. That is what the map and reduce it. Map processes the data. Okay. Data is processed locally on the data node. Key value pair is generated after map has processed the data, and on that particular intermediate key value pair reduces work and generate the output data. The logic is entirely your own logic. How you are going to write it and is for your need. Is that clear, Gaurav? Okay, and Sandeep had a question. .xml and .jar files are for what? Basically, they have some information related to job, Sandeep, the job that has to be submitted. Okay, we will not take a deep delve into that, but it is related to the job. Okay, number of maps is equal to number of splits. Why? Because based on the input splits, all the file which is splitted will be placed on those many data nodes. Okay, and onto each data node it has to be processed. So for each data node you require a map to process the entire file and then a reducer. So number of maps is equal to number of splits. Does that answer your question, Sandeep? Anand is asking, is map like a pointer? No, map is not like a pointer. Mohan, the point is, Mohan is asking if I understand right, a job is split into maps. No, Mohan, a job is not split into maps. Maps are programs. We'll see how exactly maps and reducers, the logic what are written later down in the classes. Okay. But for this point of time, consider them as two different programs. Okay. Split is something that is created. Split is something that is created for the file. That is the input split. File is splitted into those many blocks, is placed onto the data nodes. So on the data nodes, the maps has to be sent across onto all data nodes so that the entire file is processed. Okay, so that is the reason you require as many maps as there are number of input splits. For each split you need a map. Yes, Mohan, for each split a map is needed. It is only one program which is taken care by the job tracker. It sends it across. We'll see that map reduce program later on down the line in the map reduce class, how exactly it is. And we'll have some kind of a demo over here which can show you how the map reduce percentage and things really go on. Okay, Sandeep has a question, but one map program can be distributed to all data nodes. That is very true, Sandeep, that one map program can be distributed to all data nodes, but then the maps are distributed. Okay, try to understand it in this particular way. As many maps as split, you have written one program, but there are as many maps as splits are there. So what exactly is happening on all the data nodes? You have to send across the maps. So how exactly do you know that how many maps will be created? This is based on number of input splits. Is that clear to you? Did I answer your question, Mohan? Okay. Fine. Okay. This slide is clear to all of you now. Okay, we'll have more clarity on map and reduces as we go down the classes when we really have the map and reduce class. Okay, so let us go to the next slide. Okay, on this particular slide, do you see something written as heartbeat? What exactly is that? Can we have a one-liner definition from all of you? Okay, yes, everyone has answered correctly. Stay alive, a health check, kind of a report. Communication is alive between two channels. Yes, that is what the heartbeat is. Now see over here, the job tracker, okay, picks up the task. Okay, now all the task tracker are sending heartbeat to the job tracker to tell the job tracker that we are alive and we can be assigned tasks, and that is what heartbeat is all about. Okay, so it knows that which of the task trackers are alive, picks up the job and assign it to the task tracker. That is what this slide is all about, that it has to know which task tracker is alive, and based on that it assigns the job. So I think this slide is clear to all of you. This is there's not much to discuss on this particular slide. Okay, so is it clear to all of you? Can we have quick yes? Blue colored block, Samir asks, blue colored block, Samir, is the job that is to be assigned to the task tracker. So we what it is showing over here is only one blue color block to give you an explanation that okay, one of the blocks is assigned to the task tracker. Okay, so we have a yes from Sandeep is asking why H1 create as a blue. I hope I answered that question, Sandeep. Okay. Rohit Malik, doesn't a wrapper run to assign task? Rohit, at this point of time, I'll give you a one-liner explanation to it. Let us not talk about any wrapper or anything. It's the job tracker that assigns the task to the task tracker. That is what really happens. Is that okay? So Rohit says okay. So let us go to the next slide. Okay. Now see over here. A job tracker, we have listed out everything over here, and you see a blue block again. Okay, a task tracker. Now see, the task tracker over here, it has the blue blocks which lists out the map slots, and this is the reduce slots. Remember, these two are the configurable parameters which will take a look where the parameters and things can be configured. There are particularly files, configuration files for Hadoop cluster. We can take a look later on into the second class when we really have a hands-on. There we can go ahead and configure max map slots and max reduce slots. But at this point of time, this is the task tracker. Okay, these are the maps that process the data. These are the reducers which works on the data processed by the map. Okay. Okay, Mohan, I'll go a bit slow. Thank you, Mohan, for pointing me out over there. Okay, so let me start once again. Job tracker picks up the job from the job queue. Okay, the job is assigned to the task tracker. Okay, I think that point is clear to all of you, that job from the job queue, job tracker picks up the job and assigns to the task tracker. Is it clear? Then we can proceed further. Okay, Sandeep says yes. Can we have more yes from all of you? Okay, so I'll take that as a yes from everyone. Okay, so on the task tracker, we have shown over here, it's only one task tracker because we wanted to specify what exactly it's about map and reduce, but there will be data nodes in a live environment onto which things go on. Okay, so at this point of time, just take into consideration, okay, just let us leave this particular diagram block, okay. Think about it in such a way that you have data nodes, okay. One data node has one data block, and for that one data block, one reduce program is sent to that particular data node. Okay, now what will happen on that particular data node? The map program will process the data. Okay, it will process the data on that particular data node, will generate an intermediate data, a kind of a key value pair, okay, onto which the reducer which is sent across onto that particular data node will work. Okay, similarly it happens for all the data nodes, and this particular result is given to the user. The reduce part actually works on the intermediate data, generates the final result for you. Okay, that we will see. We will see a small example today that how exactly things work. Okay, so this is what this particular diagram is all about. This lists out the map. This lists out the Mohan is asking a question. Can you give example of the key value pair? Okay, fine. I'll give you an example. Okay, for suppose you have 2 or 3 different places. Okay, and from one place you have to reach out another place. Okay, you know the distance from one place to the other place, and let us mark it as, say, let me draw it out over here. It will be easier for you. Okay, so Samir is asking shuffle between map and reduce. Devashish is asking please include more examples to explain. I do understand that it's a bit difficult initially to understand things. Okay, but what we can do is you will get a better explanation, I would say, Samir and Devashish, in the later classes when we really do a hands-on on the cluster, okay, and when we really go down to the map reduce class. This will give you a better explanation then. Okay, for this particular time, what we'll do is we'll restrict ourselves on the questions which you have. And to answer your question, Mohan, about the key value pair, I'll simply give you something like, for suppose this is a statement. Okay, for suppose this is just any statement. I am in a country, in a place, any statement. Okay, now for suppose I need to count the words, okay, how many times they have occurred. Okay, for suppose there is a word called as I am in a country. Okay, so those are the words. Now for suppose when mapper will work, what will it do is it will come to know that there is a I over here. It will say, let me write it down on this line only, I, number of time it occurred, 1. Then again, am, number of time it occurs over here is 1 again. Okay, similarly it will go ahead. Okay, then you have in, first you will have 1 again. Similarly it goes for another in also, it will make it out as 1. So you have in 1 over here and in 1 over here. Now what the reducer will do, okay, it's going to combine these. It will take this as a key. Okay, It will take in as the key, okay, and will write it out 2 as the number of occurrences of that. Does that give you some insight into how the map reduce is? Okay, so we had a small example. Okay, thank you, Rohit. He says yes, excellent. Thank you, Rohit. Okay, so let us go to the slide. Should we go ahead to the slide? Okay, fine. So now I think this task tracker part is pretty explained to you. I explained this max map slot and reduce map slots. Don't worry, these are some configuration parameters, or rather say tunable parameters, why they are there and things. Those will be taken on in the later class. Okay. So just don't worry, just look at them as some kind of a configuration parameters. I explained to you how the task tracker things go on. Okay. And it says read into local disk. What exactly? It reads into the local disk for this job XML and job.jar, that what exactly is to be done. Don't worry on this particular part. Do not worry. We'll take it up. We'll take it up when we really come down to submitting a job and seeing a map reduce. That point of time we'll take this part up. But at this point of time, just try to understand that this file, since it was, you could take a look over here, that this file was there into DFS. So this has to be read from the DFS. Okay, some kind of information is there. Just at this point of time, we'll take up that only. Okay, so are we clear on this particular slide? Sandeep says yes. Can we have quick yes and smileys? Mohan says yes. Dinesh says yes. Come on, guys. Come on. Mohan says. Okay, so Mohan says, I presume you read from. Yes, a kind of Mohan. Will have an explanation on that. Okay, so let us go on to the next slide. Okay, so for these particular slide, I'll hand it over to Abhishek again. Okay.
Hi guys, I'm back. I just took a coffee break. I hope you enjoyed the session with Rahul. He'll come back again once again now. So let's get started with this one. And I hope you've understood in detail that how does a job tracker and a task tracker work. Can I quickly get a yes or a no if you guys have understood what Rahul just explained? Okay, Mohan, don't worry. I mean, don't worry. We will have this in more detail next time. Okay, so don't worry about that. Okay, so Gaurav says Rahul did a great job. Okay, great. Very well basics. Okay, fine. So I think most of you people have understood some things, and for those who have not, we can always take these things. Next session will be completely hands-on. So we'll be looking at these tasks running on the machine. So there will be as it will be as good. It will be very good there. Okay, you will be able to figure out everything very clearly there. Okay, sure. So. Okay, thank you, Devashish. But I think let's get started now. Let's try to understand what are the other things. Okay, keep writing on the chat window. Okay, so Ajay is asking a question which I want to take it, though it is a little out of context here. Should we install Hadoop ourselves to learn it? Ajay, well, we will be, for the training purpose, we'll be using a Cloudera CDH4 installation. Okay, we will be giving you the virtual machine which can be run on your machine as well. And for people who do not have a 4 GB plus RAM machine, okay, they can use our own our server using a TeamViewer kind of application. Okay, so for all those people who need help on that, you can quickly contact the support team after the class. Send an email to support team. Hisham is the guy. He'll respond back. Okay, is that fine? Everyone is okay with that part? a lot of questions come in just after the class, because we'll be showing you a Cloudera demo also. Rahul will be showing you a Cloudera demo just in a while. Okay, but before that, let's try to understand how does a HDFS client create a new file. So now the next few slides will tell you how a block is added in a HDFS. Okay, how does a read and write happen in HDFS, and how is the data actually stored in HDFS. So please pay attention. It is a very these are some important concepts, okay, which you need to understand first. Okay, so now we know that there's a HDFS client, and here's the name node. You must appreciate the fact that we have used a color coding scheme to denote a name node and a data node. The graphic guy has done a great job. They've made sure that the data node is always red and the name node is always blue, probably in consistency with the Lamborghini. So please remember that, yeah, so basically the fact is that we have a HDFS client, we have a name node, we have data nodes. You know that the data is actually written on the data node. Okay, so what we start with is the HDFC client, sorry, not the HDFC client, but the HDFS client tells the name node that I want to add a block of data. Okay, it sends a block add request. Okay, now the name node, what it does is, it figures out which data node should the data be written on. Okay, so that is something which the name node will be knowing. We saw in the earlier files that there's metadata stored in the name node, which it will be knowing which all data nodes are have space to take this block. So it gives this information back to the HDFS client. Okay, I'm in love with HDFC somehow. Okay, sorry. So it gives this. HDFS client. I'll not call it HDFS. The client sends a request to add a block of data to name node. Name node gives back the information to the client on the nodes which are available and where the data should be written. Okay. Then the client goes and writes the data to the data node. Okay. So now the data, one thing which should be very clear here is that the name node does not write the data on the data node. It is the client which writes the data. Okay. While the write is happening, the name node is not involved at all. The name node just gives the metadata and the information where it should happen. Okay. And I'll also tell you very clearly that what is the logic behind deciding which data node should be written to. That will come now. So don't worry about that. Okay. So you've understood this part, that the client sends a request to the name node that I want to write some data. The name node gives back the information that where to write the data, and importantly, the client goes and writes into the data node. Okay. Is that clear to everyone? Guys, can I get a quick yes from everyone if this is clear? Good. Yes, client is the end user, right? So client, as I told you, is an application which is used by the end user. Okay, it's an application which is used by the. Okay, so Yashwant is asking a question: if the data node is full, how it's identified? So as I told you, Yashwant, the name node keeps that data with it. That what all data is stored on each name node, all that metadata data about that data is stored in the name node. So name node will be knowing that that this data node is full now. Is that fine, guys? Okay, good. Now I've also written that data pipeline. Now the way the data is written is that the data is the default replication factor is 3. Okay, that's what we learned earlier. Okay, so the first data the client will write on the data node. Then the client, I mean, we will explain this in more detail. Then this data node will write the data in the second node. And the third then the data node will write the data into the third data node. Okay, so it is a pipeline write. Okay, I will ask a question on this later on, so please make sure that you understand this properly. And I'll explain this in detail as we move ahead in the next slide. So Sandeep is asking me a question. As per this logic, need to response with cluster and client for writing the data. Sandeep, I could not really get the question. Can you rephrase it, please? I'm not so good in English. Sometimes I falter there. Can you rephrase it, please, while I move ahead? Yeah, client will talk to the name node, correct? And then, yes, that's what we saw earlier also, that the client can talk to both the name node. Yes, you're right. So Sandeep, this is how it happens. The client will talk to the name node first, then it will get the data where to write, then it will start writing to the data nodes. And it will write to one data node. The second data node will be written by the first data node itself. So as it is shown here, the write operation on the second data node is taken care by the data node. Okay? Yes. Is that clear, guys? Yeah, we have a very good question from Anand Kumaran. He says, on what base name node will decide which data node to write? Okay, so I'll give you a very, very technical kind of answer, which I'll explain in very simple words. Okay. The whole idea is, and I'll explain this in more detail, but really good question. Did anyone else had this question in their mind? We should all appreciate Anand for asking that question first. If anyone had this question in their mind earlier, on what basis will this be decided that which data node to write? Okay, so let me answer this question. So, at a very, very high level, it will decide based on the fact that all the three data nodes should be as close as possible. Okay, number one. Number two, the data nodes are decided based on the fact that if there is a fault, then the minimum impact should be there. Okay, so these are the two things. Now, in the next slide, I'll explain you what is the exact scenario used there. Okay, so just give me 1 second. This question will definitely become very clear. Okay, is that fine, guys? So basically, it is decided on two factors. Number one, to make sure that the overall system is more highly fault tolerant. Number two, that the total time or the total effort required in writing is minimal. Okay, these are the two things which will be the factors based on which name node will decide that which data node should be chosen. Is that fine, guys? We'll explain more in detail in the next slide. Are you guys with me? I am not getting any yes or no. Are you able to hear me, guys? Am I audible? Okay, great. Thank you, guys. Please, yeah, Rahul told you about that heartbeat, right? So please keep giving me that heartbeat, otherwise I'll throw you out of the system. Okay. So can I get a quick heartbeat from everyone? No one is giving me a heartbeat. Okay, thank you. Mohan has not given me a heartbeat. Mohan is a little lazy. That's okay. Okay, thank you. Okay, let's move on. So yes, Anand, since you asked that question, I quickly prepared a slide on that right now. Okay, and I thought I'll just do some magic for you. Okay, so there's something called rack awareness. Okay, so Mohan, so while we were talking, Mohan had this question that on what basis will the data be stored, on the rack or on the data nodes? Okay, so let's see this. This is going to answer that question. So what we have here is our three datas. One is bad English, but three set of data. Okay, block A, block B, and block C. Okay, rack 1, rack 2, and rack 3. Everyone knows what a rack is? Quickly, heartbeat, guys. Okay, and each rack will have multiple data nodes. So let's assume this is a very simple. Yashwant says I'm not able to hear you. Guys, are you able to hear me? Everyone else? Yashwant, there will be a problem with your side then. Okay, Yashwant, just check your internet connection. Okay, great. Thank you. Sorry for the interruption, guys. So each rack has a set of data nodes. So this 1, 2, 3, 4 is actually a very simplistic way of putting a data node. Okay, now these racks can be located physically at different locations, but one rack will be at one location. Is that fine? So 1, 2, 3, 4 is data node here, 5, 6, 7, 8 is data node here, and this is the data node here. So each data has to be written thrice, right? Does everyone remember that? So let's see what happens to block A. So block A first is written to rack 1. Okay, it can be written to any rack, but first will be written to some rack. Okay, and the second and the third copy of the block will be written on a separate rack and not on the same rack, but on a separate rack on two different data nodes. Okay, does this make sense? Can anyone tell me why do we do it? Why can't we write 5 and 6 at 2 and 3 itself? Can anyone answer this question? Yes, fault tolerance, right? Very good. So if there is a rack level failure, then we will be able to take care of this situation. Then why did we not write the 6 at the third rack, guys? Yeah, very good. Samir is my man. He asked me the question, why not 6 and 9? Sandeep has given me some answer. Anyone else? Proximity is what Gaurav says. Okay. Yes. More people. I want more answers. People, guys, if you are confused, please answer something. No one else is seeing your answers. You don't have to worry. So the teacher is not going to expose you. Okay. Okay. Quite a few. Ajay has given me an answer. Okay. Yeah, Rohit, we can, Rohit has also given me an answer. I'll answer that. Guys, I want Sayyid to answer it now. Sayyid, quickly. And if I'm missing someone, I'm really sorry, guys. I try to remember all the names, but Rahul, where are you? You're gone. Yashwant, you're able to hear me now? Okay, Rahul, can you answer quickly? Why is, can someone resolve Samir's problem? Samir has asked me a question. Why is, yes, okay, great, Yashwant. Yashwant, can you try to answer this question on the chat? Why is 5 and 6 stored in the same rack and not on rack 9, on rack 3 and 9? Okay, so I have quite a few answers. Samir, a lot of your friends have actually helped you. And the answer for that is that, see, there is a very less probability of having 2 rack failures. And we want to have a trade-off in terms of speed of write as well. If I have to write on 3 racks the same data, it takes a lot of time to write and it will be a waste of resources. Okay, so the second and the third copy are always written on the same rack, but on different data nodes. So in case the data node 5 fails, you still have the data on data node 6. So this way, what we have taken care of is we have taken care of rack failure tolerance. We have also taken care of data node failure. Is that fine, guys? Is everyone clear about that? For very critical data, you may want to create more replicas. Okay, then you may think of writing in a different rack. Okay, but at the same time, with a 3 factor, no one actually does anything more than this. This is what is usually done in the industry and the production environments. Guys, everyone clear with this? This is an important concept. Can I get a quick yes or a smiley from everyone? Great, great, great. Mohan, is that fine? Or it's kind of fine, or? Okay. What if rack 2 and data node fails? See, what if tsunami comes and we all go for a toss? Okay, so I mean there will be some things which we cannot. I mean you can keep preparing. Do you think I should wear a helmet and sit in this class because the fan may fall down? Samir is asking me, what if rack 2 and data node 1 fails? So we have to take some risks, man. You want me to wear a helmet and sit in the class and teach you? Are you wearing a helmet? Yes, so we can. Yes, for critical data we keep more replica. Okay, but there will be some, you cannot prepare yourself for everything. Otherwise, you will not be doing anything. You will just be keep on writing the data. See, the idea is not only to write the data, but to read the data back. Okay, so if I waste a lot of effort in that, there has to be trade-off between. Thank you, Rahul. Thank you very much. I really appreciate. Rahul has appreciated me saying you give great examples and given you a big smiley. Does anyone agree with that? I want to boast a little bit. Gaurav Tawar is also giving me a smiley. No one else is giving me a smiley. No, Sandeep Ganguly says no, you don't give. Sandeep, I'll tell your wife, man. Okay, guys. So let's move ahead. Let's see what happens to block B. Okay. So block B, let's assume that block, as I told you, right, the first can be chosen based on the proximity, and it happens to end up at rack 2. Okay. Can anyone tell me where will the other 2 copies of block B land up? Quickly, can someone tell me? Rahul Tiwari, it says 10 and 11. Rack 3 says Yashwant. Okay. Sandeep says rack 1 or 3, 9, 10. How can you be so sure that it will be 10 and 11? Okay. Right. So no one is actually, the good thing is no one is giving me an answer that it will be either on 5, 6, 7 or 8. So that is something which you've understood. Right. Mohan, it can be in rack 1 as well, right? There's no reason why it should be only on rack 3. Okay, so let's see where our friend Hisham has put it. So yes, I mean, I think there was some collusion with Rahul Tiwari. Rahul and Hisham would have prepared this together. So, and Mohan, you have been proven right. It ends up on rack 3, but there's no reason why it cannot end up on rack 1 as well. Is that fine, guys? It's just coincidental that it ended up on rack 3. Okay, great. But the fact is, the 2 things which have to be remembered: first copy on a same rack. Okay, Mohan told me that, yeah, more space on rack 3, right, Mohan? That is definitely there. But we did not tell you what is there on 9, 10, 11, 12 also, right? These data nodes may be having a lot of data. And yes, rack 1 and 2 might be there, right? Yes, that's also right, Samir. Okay, so let's see what happens with block C. So now that everyone has understood, I know where it will happen and what will happen next. So is this clear to everyone? Anand, your question is answered. Did you like this magic? Anupam, you are clear with this? Yes, I got a yes from your side. Great, great. Cool, cool. Anupam, are you enjoying the class? I did not ask that question from you specifically. I just wanted to ask you that. Are you having fun? Thank you very much. He says very much and gives me a big smiley as well. Okay. Anand Kumar has... Yeah, Mohan, I'm waiting for your full question to appear. Meanwhile, okay, whenever you send a data to a node, do you allow settling in time? Yes, yes. Okay, very good question, Mohan. Now, this question you have to keep with you. I'll do another magic. I'll tell you how this is maintained. Okay. So Mohan has asked me a question. When you send the data to a node, do you allow settling in time? What Mohan means by that is that do you make sure that the data has been written before you do any operations? Right? Is that what Mohan you're trying to ask? No. Okay. Okay. Please repeat your question. Okay, I think I got your question. I think I got your question. I have Mohan, just give me 1 second. I'll answer a couple of questions and I'll come back to your question. Is that fine? Okay. Mohan, just give me 1 second. So Suman has asked me a question. Will the second and third copy always happen to in the same rack? Yes, Suman. That is what we talked about, right? The second and the third copy will always be on the same rack. And this is to make sure that we don't end up spending, see, writing in a separate rack requires a lot of operations. I've not gone into the operation level detail here that each write will require a lot of operation. If it is on a separate rack, there will be a switch here, okay, on which the write will happen, then it will transmit to the data node. So if you're writing to a third rack, it takes a lot of effort. So we don't do that, okay? And block ABC are parts of a single file. ABC, no, not necessary, Sandeep. They are different blocks. Okay. Yes, Mohan, I've understood your question. Now Mohan has asked me a question. I'll just collate everything. So whenever you send data to a node, do you allow settling in time before committing the data to the node? Okay. Because when you send the data and the maps of software associated with it, the processing can get loaded. Yes, Mohan, we do allow some time before we read the data back, or we let the process get started. Okay. Have I understood your question correct, Mohan? Okay. What we'll do, Mohan, is we can have a discussion on this after the class. Yeah. I'll let you speak. That's fine. I'll let you speak. So Mohan wants to speak and I want to ask a question. Where is Mohan? Give me 1 second, Mohan. I'm not able to actually unmute you. Yeah. Yes, Mohan, you are on air now.
Okay. Okay. I'll tell you what my real question is. When you're sending a block of data, right? I mean, you're sending data and the map program that's associated with it to every single node. I mean, the rack, right? Now, when you're sending, when you're filling up the different nodes and different racks with the data and the associated program, I mean, it takes there's a lag time for the machine to basically load up to full load, isn't it?
Okay, yes.
When you're processing this thing.
Yes.
So do you, when you're distributing all this across multiple nodes, do you give some sort of a lag time or lead time in order for it to, some sort of a lag or a lead time for it to settle down? Or is it that you just go in and say, chuck, I'll just fill it all up?
Okay, so Mohan, when I showed you in the last slide also, we give time, and it's not like a posted write, it's a non-posted write. I'll explain that term to everyone else also. We wait for an acknowledgement back from the data node. Okay, we wait for an acknowledgement back from the data node. So it is the responsibility of the owners of data node to make sure that the data is settled, and unless and until I get an acknowledgement back, I assume that the data has not been written. Okay, so that is how that part is.
I'll tell you some history, because
okay.
we in our current situation, we don't use Hadoop. We wrote our own grid manager because it was about 3-4 years ago.
Great.
And one of the real big issues that we ran into is that since we were not boosting, I mean, we were not giving a time boost to this thing. I mean, all of a sudden, you had machines that were saying that they were freer than they should be, and everything was basically being pushed towards those machines. And I was wondering whether Hadoop had a way of taking care of something like that.
Okay, so a very, very simplistic way of doing this in Hadoop is that as soon as I write some data, okay, I will wait for an acknowledgement from the data node or the task tracker. Okay, and right, so that will tell you.
Do it. Yeah, I think you answered my question.
Right, right, and I'll explain that. Okay, that's what we do. Does that answer your question, Mohan?
Yeah. That will do it. I just wanted to know how this is done in Hadoop.
Sure. Because, this is something which we'll be covering in the next slide as well. Okay. So just allow me some time. Okay. Just allow me some time. Okay. I'm sure everyone else is has understood this question, guys. It's a very, very important question, and Mohan gave us a real life scenario where he actually had a problem. So I mean, these are the kind of insights which we get when we have people like Mohan and others here. I mean, and I want everyone else also to actually contribute in this fashion. I'm sure everyone has their own real life experiences. If not today, you guys are taking some time to settle down. I believe from next time onwards, you will come up with some scenarios from your life as well, right? Which we'll discuss in this session. Is that, will everyone promise me that? I don't want this to be a lecture kind of scenario, right? Can everyone give me a smiley? Mohan, you can say yes. You don't want to write. Okay. Thank you.
Another thing, it would be nice if you can give a lot of examples as you go along. I mean,
sure.
Otherwise it becomes very abstract, right? I mean,
right.
Like the name value pairs that I asked about.
Don't worry.
How others.
No, I'll tell you one thing. If I were in Rahul's place, I would not have covered name value pair in this class. Okay. I strictly say no, we will not talk about it. We'll talk about it when we reach class 3. Okay, because otherwise we'll get, I mean, there's so many details. I've skipped a lot of details in this diagram also. I can send you a diagram which actually Yahoo uses. So I don't want to get into that right now. Believe me, by the end of class 3, you will get all those things clear.
Yeah, okay.
Fine? So let's move ahead. I'll mute you back, Mohan. Okay. Thank you.
Yeah.
Okay. Now everyone, you can thank Mohan for that, and I'll move ahead. So this is clear to everyone. Let's see how a write happens now. Okay. So something which Mohan was asking, and I will also ask this question to you, and let me show you how this works. In this diagram also, don't worry too much about what are these things. It's very, very simple. And we'll understand it in a very, very simple fashion. In the next class, we'll be seeing all these things happening on a cluster. Okay. So we'll see it happening on a cluster in the real life. Okay. So now what we're going to do is, let me tell you what happens. Let's start. So as we said, right, when we say create command, it creates those input splits. It goes to the name node. Name node gives this information back that which data nodes to be selected. We've already seen which data nodes to be selected. And then we write this packet on the data node. The client will write the packet on the data node and no one else. Okay. It's not the name node. That's a confusion which is usually asked. I keep asking that because people ask these questions in interviews, and anyone who is looking to crack a job interview will appreciate this, though Rahul does not appreciate that. Okay, but so basically people will be writing this. So the data will be written by the client on the data node. Okay, the first data node will be written. It will send the data to the second data node. It is a pipelined write. Okay, the first data node will be written. It sends the data to the second data node. Then the data reaches the third data node. And to answer that problem, see the problem which Mohan was facing, there is an ACK. So the ACK means that this data is, there is an acknowledgement back from the data node, which comes to data node 2, and then it comes back here, and then it goes to the client. Is that clear to everyone? Now this is a posted, this is a non-posted write. Now there are two types of writes in this world. The one is posted and the other one is non-posted. Does everyone know what posted and non-posted write is? Quickly, can you give me yes or no? Anyone who knows yes? Rohit, knows it? Okay. Anyone who knows about the difference between a posted and a non-posted write? Quickly, guys. People are not even writing no. They are not writing yes. Are they confused? Did I not? I am not audible to you? I mean, there are only two answers, right? Yes or no. I have not got a no from everyone. I have not got a yes from everyone. Okay. I have got a no from everyone. Good. So let me take a lot. Let me just answer that question. Okay. Okay. So basically there are two types of writes in this world. One is posted, the other is non-posted. Posted write means that I write it and I forget about it. Okay. It's like, let me take an example. So it's like the difference between a letter which you send by India Post and a letter which is sent by a courier service. So in a posted write, you just post the data. You don't worry about the acknowledgement. So something which Mohan and his team were doing earlier and allowing some time to settle down and assuming that the data must have been written. Okay. In a non-posted write, though it is more expensive, but we wait for an acknowledgement back. Okay. So it's like the acknowledgement which you get from a courier company. It's exactly the same thing, the same analogy. Posted write and non-posted write. Posted write is I posted, I forget about it. I believe in 3, 4, 5 days it would have reached it. Okay. In a which Mohan and his team were doing in their grid manager, and Hadoop took a little more smarter step. They implemented a non-posted write and they wait for the acknowledgement. Okay. Thank you guys. Well, all the writes are asynchronous. Okay. There are quite a few questions which are coming in. So Sandeep has said that this time you have given a good example. Thank you, Sandeep. I also appreciate you this time only. Last time I didn't appreciate you. Okay. Thanks. Okay. Now Rohit has asked, is it a synchronous or asynchronous? So there is no relationship. All the writes are asynchronous. So you write. You're not writing it synchronous. You're not it's not that a write happens and then the whole system stops and keeps on waiting for the acknowledgement. You write, you keep on pushing data into the pipeline, but you assume that the write has been done only when you get an acknowledgement. Okay. Does that answer your question, Rohit? So you will not do any operation. You will not assume that the write has been done unless and you get an acknowledgement. But you will not stop the other writes to happen during that time. Okay, so the client will keep on pushing data and keep so it's like a queue implementation. Okay, it is actually implemented in a queue where there's a job queue and there's an act queue. Is that fine? Is everyone clear about that? Rohit asked a very good question. If you go to interview in Rohit's company, Rohit must ask you this question. Okay, so please make sure that you that you understand this well. And Rohit is a senior guy. Okay, so what happened if middle of the node pipeline failed? Okay, yes. So if it fails, then it will assume that it has failed, and it will it will go back to the name node and ask for a new data node, which will be allocated, and that information will come to the task tracker, which will make sure that the data is written to a separate node. Okay, so if this fails, it will ask the data node, which is the next one. Data node has already, name node has already given this information. It will write here. If this fails, then it will find out which are the other two nodes. Is that fine, guys? Ajay has given me a smiley, and I hope, and I believe it is not for the example, but for the fact that Rohit will ask this question. Right, Ajay? And I have a question from Gaurav here. Gaurav says, does it mean that replica data writing is done after the ACK is received post writing the first node? Yes, that is true. Unless and until the client gets an ACK packet back, it will not assume that the write has been done. Does that, okay. Okay, now there are few more questions, which I'll be very happy to answer. See, this session is the first session, so it may actually, it may extend in time. So please bear with us. We still have a lot of things to cover. Okay. Anyone looking to leave had a hard stop at 5? Can you tell me quickly? Do you have time? Can you extend it by 20-25 minutes, guys? Will you mind that? Rahul, Rahul, the fact is that if I do not get an acknowledgement, I'll assume that it has failed. Okay. Vidyasagar, see, the way it works is that if a data node fails in between, the data node, the task tracker, which was supposed to write the data on the second data node, will go back to the client and tell it that it has failed, and it will ask for the next data node to be written. The client will give that information and it will write it on the next data node. Okay, if the second data node also fails, it goes back to the client. The client will ask this information from the name node if all the data nodes have failed. Is that clear? Is that clear to everyone now? Yes, yes, Anand, you're okay. Okay. So Ajay, is this clear now? I mean, see, basically, I'll explain it once again. Okay. Ajay has to leave at 5. Okay, Ajay. So Ajay, you might miss a couple of things, but don't worry, you'll get the recording of the class. You can go through that and keep asking questions from us. Okay. Okay. Thanks. Okay. Samir, sure, I will take care of that. Okay. Sure. Thank you guys. Thank you very much. Now let me explain this once again because it's slightly important. As I told you, in case of Hadoop, we do a non-posted write, which means unless or until the client gets an acknowledgement packet back, it does not assume that the write has happened properly. Okay. Is that clear? Now, second thing, if for some reason the data node in between fails, then the client will then the data node which is supposed to write on the second data node will go back to the client, ask it which is the next one to write to. It will get that information, it will write on this one. If this also fails, this guy goes back to here and asks it that which is the one to be written, and this guy does not know it, so it will go to the name node, ask which one to be written. This will give this information back. This information will come back to the task tracker and it will write to the last one. Now, is this flow clear to everyone? Can I quickly get a smiley or a yes from everyone? If there's a confusion, please write back. Good. Good, guys. Thank you very much. Thank you very much. So I'm assuming that everyone is clear with this. Okay. So everyone now knows what a posted and a non-posted write is? Good. So Vidyasagar is asking a question that will there be an ACK pack for a write on every node, or is it done for every 3 nodes? So Vidya, the way to the client, there will be just one ACK. Okay. But there is a ACK, if you see here, right, this 5, it is this acknowledgement is coming back from this data node. So this is one acknowledgement, then this acknowledgement coming from this data node, second acknowledgement, this is the third acknowledgement. But for the client, it is just one acknowledgement because it is a pipeline write. Does that answer your question, Vidyasagar? Samir, was this question clear to you? Samir? Okay, great. Thank you. Okay, so let's move on, guys, and let's see how our write works. Okay, we've seen how our write works. Let's see how our read works. Okay, so now what we have here, it's very simple. The client goes and gets, the client tells the user tells the client, I want this information, this data to be read. The client goes and asks the name node, okay, and the name node, what it does is it gives the block information from where to read. And this time, Samir, just give me 1 second. Don't worry about that for now. Okay, so this time the client goes and reads the data from all the name nodes in parallel. Now this is not pipelined. Can anyone tell me why? All of you should be able to answer this question. We saw that the write was pipelined, but in the read case, we are seeing that there are these parallel arrows. We are reading data from all the places. All the people who have so many, Vidyasagar is giving me an answer, we need to read it only once. Well, shortest path to get the data, streaming data access, information, no one is giving me the right answer. Can someone else tell me? Anand says we have map keys. No, these are independent data sets here. The same data. This is the same data which is written in 3 places. Okay. But we are reading it from 3 places in parallel. Why is that? Write once, read many times. No, that's not the answer. See, the whole idea, need to read the duplicate data as well. Yes, Yashwant, that's true. And the whole idea behind Hadoop is writing is not a problem. Writing is not a problem. Write you can do as slow as possible. See, we read once, we want to read it fast. Right, Anupam? Right. So basically, if for some reason, if I had to read it in one by one, if this fails, right, then I'll have to go and read again from this. So what I do is I go and read from all the places where the data is replicated. If I get all the data correctly, then, I mean, there are obviously checksum and such techniques applied to make sure that the data is consistent. But if there is a failure in one of the nodes, I still get the data fast. Is that clear? Everyone got that answer? Can I get a smiley? Because this question can also be asked in the interview. I asked this question many times. Rohit, you can also note this question, man. You can ask this question to the people who are coming in your team. Okay. Mohan can also ask this question. Okay, great. Yeah, thanks, Rohit. Yeah. So we are building a question bank, guys. Now, what I would love to have from you guys is that if after the class, you can just quickly, okay, sure, Mohan, no problem. I'm really sorry to bother you for that. Okay. So guys, the questions that you've asked, we'll try to create a knowledge bank of all these questions and we'll share it with you. In case we'll really love if you can just write down your questions again and send it across to the support team so that their job becomes a little minimal and all the commodity hardware can do the work. Okay. Yeah. So please, I'd just like you guys to write only the questions which you asked. Okay. And the answers which you think are the right answers. We will create a great body of knowledge which you can always keep with you. Okay, throughout the course, and this will be available to you for the life. Okay, so do you promise that you will please? Yes, we will do that, Rohit, and this is how we are going to create this. Okay, so guys, do you promise me that you will at least note down the questions you asked and give us the answers so that we can all learn together? Can you promise me? Can you everyone give me a smiley? Okay. Yeah, whatever you remember. You don't need to write everything, but whatever you remember, you can write it down. We can also compile everything. We have a record of all this. Okay, great. Great. Thank you, guys. I did not get a response from a few people who will be a little lazy to do that, but I'm still fine. Most of the people have responded in a yes. Okay, Anupam has also. Thank you, Anupam. I was actually waiting for your response. Thank you very much. Okay. Yeah. So we understood this. Now, basically, what we have understood today is one in this slide that the file read will happen in parallel, and this is because even if the data node fails, we don't want to end up not reading the data fast. Okay, we started with the fact that the whole idea of having Hadoop is to be able to retrieve data fast and do fast analysis on big data, right? So this is how it will be accomplished at a lower level of architecture. Is that clear to everyone, guys? Okay. Okay, good. So I think with this, for today, this is all we wanted to cover. Okay, I'll quickly do a quick snapshot of whatever we've done today, and I'll not show it in a slide. I'll just speak out. Okay, and then I will ask you questions. Is that fine, guys? So we started with what is big data, what is the scenarios where big data is used. We also spoke about unstructured and structured data. Everyone is clear with that? Keep on answering that with a yes or no. Okay, so structured, unstructured data we talked about. Then we went on to understand why do we need, what is the challenge behind storing data. It's not the storage space, but the IO. That was the second point which we covered, right? Right, guys? Don't be frugal in writing yes or no. Okay, yeah. The third thing which we saw was that a distributed file system can be a probable solution, right? That's what we saw, correct? And then we came to Hadoop, and then we saw what is Hadoop all about, how does Hadoop solve this problem. Then we went on to a little more detail when we said that there is in the Hadoop cluster there is something called a map reduce, there is something called a data node, there is something called a name node, there is something called a job tracker, there is something called a data tracker, task tracker, right? If anyone has any confusion or anything, please say no in this, right? Then we went ahead and then we saw in detail how a job tracker and a task tracker work, how the whole block of data is split into multiple, there is an input split which happens, and how is it distributed over the DFS and written over the DFS. Then we went into the details of how a block is written. We also saw why rack awareness is needed. How do we make HDFS a fault tolerant system? Is that correct, guys? You remember that rack awareness slide where I should thank Anand for asking me that question. And then we had a lot of questions from Sandeep, Rahul, Mohan. Then Mohan asked us a question regarding how do we take care of, how does the write happen and how does it take care of the problem which he was facing in his earlier implementation of the grid manager. We answered that question. In fact, not I, Hadoop actually had an answer for that using the non-posted write, right? Was it a posted or a non-posted write? Guys, what is a posted or a non-posted write? Great. Anyone thinks, Anupam, Sandeep tells me, no, Sandeep, posted is the write which happens using India Post. You don't get an acknowledgement for that, right? When you post a letter, okay. With ACK, it is non-posted write. Is that clear with everyone? Very good. So everyone has understood that as well. Very nice. Now, then we saw that how does a file read happens, okay. And in the file read, we looked at why the data write happens in parallel. Data write happens in a pipelined mode, and why does a data read happen in parallel. So explain this once. Is that clear to everyone? That is what we have covered in this 3-hour long class, which was as long as a Mughal Azam. Okay, or I hope it was not as boring as a Savaria. If everyone has seen the movie Savaria, I'm sure everyone has heard about it. Hardly anyone has seen that. Gaurav has seen it. So Gaurav, you have a great level of patience, man. Thank you, Sandeep. It's a good example, yeah. So Gaurav saw it, okay. Samir has a question which remained unanswered. Samir is, okay. Okay, Samir, give me one moment. I'll answer that. No question will remain unanswered today. Okay. Don't worry. Every question will be answered. But you'll have to give me some more time. Okay, Samir? There are more important things to cover right now. Okay. I'll answer this question. And I don't think everyone is interested in that question. I'll answer that. Okay. Now, okay. So next thing, so we've understood all these things now. So let's go back to our Facebook example and see if whatever we have learned, no problem, Mohan, we'll send you the recording. And thank you very much for joining in the class. Okay. So we are going to show you a live demo of how a Cloudera VM works. And what you can quickly do is that after this class, go through a Dropbox link. We'll send you an email with instructions. You'll have to do that. Okay, fine. So basically, let's go back to our Facebook example now for just 1 minute and see if we've actually solved the Facebook problem. So Facebook's problem was not to dump the data. Okay, its problem was to quickly read the data as fast as possible and analyze the data. So Facebook would have implemented a pipeline write, right? Because the priority is not to write the data fast. Data is written, it can, even if I analyze the data after 1 day, it's fine. But when I start analyzing, I want a fast streaming access. Is that clear to everyone? So does this solve that problem which we started with, the business problem of Facebook? Guys, is that clear? Can I get a yes? Can I get a smiley from everyone if we were able to make a good story out of here? Good. Thank you. Thank you very much. So we had a good story here. Thank you, Anand. It was clear. Anupam, I'm still waiting for your response. Okay, thank you. Thank you. Quite a few people had to leave, and I'm really sorry for extending this session. But we still have a few more things to cover. But we come to the end of the presentation. But now what we're going to do is Rahul is going to show you a live demo of Cloudera. Okay, how does it really look like on Cloudera? Now you don't have to understand everything there. You don't need to ask all the questions there also, because the next session will cover everything in detail. This is just to give you a feel on whatever we were seeing on a PPT, how does it look like in the real system. Okay, we'll be using a pseudo single node cluster which will be having a name node and a data node. Okay, so but you don't have to worry if you don't understand a few things here. During the week you will get some assignments and the support team is going to help you with that. You just need to get a feel of it. So get a feel. Don't worry if you don't understand some details. Is that fine? Does everyone promise me that they'll not worry if they don't understand everything in what Rahul is going to teach now? Okay, great. So we will be doing this in detail in the next class. Okay, we'll take some 10-15 minutes to show you that, and then we'll go ahead. Okay, so I'll give it over to Rahul. Rahul, you can get started. I'll come back, guys. Do miss me. I'll be back in a minute once Rahul is done with this. I'll ask you a set of questions.
Hi guys. So let us get started with the Cloudera VM. This is a Cloudera VM that is available at the Cloudera website as well as at the Dropbox link which you will be getting. Okay, so you can download the Cloudera VM from there. Okay, so let us get started on that part. So this is our Cloudera machine, or rather I should say Cloudera VM. Okay, so okay, let us go and write and see what few commands are there. I'll show you few commands. Okay, and let us start with one of the most basic commands. Okay, Samir has a question. Once the course is over, will we have enough knowledge to appear for Cloudera certified developer for Apache Hadoop? Well, that is a question, Samir, we have to answer a bit later on rather than answering it now, because this is the very first class. Okay. And there are quite number of things that certification for Apache Hadoop takes care of. Okay. So I'll leave that question for a later on point of time. Is it okay, Samir? Okay. So let me give you a very basic command of Hadoop, that is Hadoop itself. Okay. You press enter, you write Hadoop, you press enter, you see so many options for Hadoop. So these are the options you have with command Hadoop, and if you want to really look for any of the options, what it basically lists out an option to that particular option itself, you have to write again Hadoop, the option, and then again press enter. It will give you the list of things. It will give you the list of entire things over here. Okay. So let's see one or two more small examples of if we really want to list out how exactly things are listed out in Hadoop. Remember, Hadoop follows a close pattern to Unix. Okay, the directory structures, the permissions and things are just like Unix as in Hadoop. This slash what I'm writing down over here is of Hadoop distributed file system. It's not for the local file system. Okay, so when you press enter over here, okay, so I missed out -ls over here. So if you go to list it out, okay, Sandeep has a question, how to install Cloudera VM in my laptop. Just hold on for a second, Sandeep. Okay, press enter. You will have this directory structure. You can look at the permissions that it specifies. Okay, that's what I told. It follows a close pattern with Unix. Okay, so is this small operation clear to you all? Okay, these are few commands. If you really want a list of commands for Hadoop, it's available at online at Apache website, and it's available at the Dropbox link that we'll be having. Okay, so let us have see, there is actually a command line interface for things. There is a GUI interface also. I'll just open up the GUI interface. So let me open it up. So Firefox has started. Okay, so okay, and I'll tell you what I'm opening up. Okay, just don't worry about that. I'm just opening up right now. Okay, so have a look. This is the port number for the name node. Okay, in this case it's the local host, since this is a one node cluster. Okay, we'll take a look on things that what other things are available in how to form a cluster and things like that in the next class. Okay, but for this point of time, the local host is there since this is a one node cluster. Okay, and this is the port number for name node. You can see many different options, many things, information on this particular name node. Okay, what all things are there? There is particularly the storage directory that is named, and its image and edits are there. This image and edits are basically, if you while going through the class, you would have gone through the concept of metadata. Metadata is stored as metadata is stored with a name called as fs image, and there is a edit log file also. We'll take a look into that particular thing in the later class. Okay, similarly 30 is the port number for your job tracker, and for task tracker 60 is the port number. So you can see all the web interfaces of these three. Then there is something called as Hue. The password for this also is default Cloudera and Cloudera. Okay, and I'll open up something called as a file browser now. Okay, let us go to the command line. I'll show you one small example of this particular Hadoop example basically. So there is particularly USR lib Hadoop -0.20. This is the base directory where your Hadoop installation is. Okay, and you have certain examples already there, example programs already written in it. Okay, so let us take this examples.jar file. How to run these particular examples? This is the command. Okay, press enter. You will get all the things available, list and everything over here. Okay, let me take you through one small example which is called as a TerraGen. TerraGen is one of the programs that generates output for TerraSort and TerraValidate. Okay, now what exactly these are we'll take a look at later on point of time, but I'll show you that what TerraGen is and how exactly it generates it, how exactly map and reduce proceed. So what I'm writing out over here is I'll give a big size. So do not worry if you get an error message or something, because the size of data that is to be generated is pretty huge. Okay, and then we'll have something else, a directory where it is going to generate the data. Okay, the directory where it's going to generate the data. I've written a bigger example so that I can show you on the web interface how exactly it goes on. Okay, but with the space available, I don't think so this is going to complete. So let us go ahead with this particular example. You see there's two maps of this, and running job map and reduce for 00% has started. It will take time to complete, don't worry, because since it's a big data. Okay, so let us go on to the name node. Okay, you see here certain things written. Let me refresh this page. Okay, the things would change now. See the DFS used, non-DFS used, DFS remaining and all those things. Okay, this remains same. Let us go to the job tracker, refresh it. Okay, it's refreshing. You can see after the refresh, you can see occupied map slot, number of nodes, total submissions, running map tasks is 2. Okay, go below. You have some job ID. This is the job ID for the job which we have run. Percentage completion of the map, percentage completion of the reduce. So reduce has not yet started, in fact. This is what we were talking about when we were going through the... Okay, so we have certain questions from Samir. This all new keywords for me. Yes, Samir, it will be new keywords and things for you. Okay, that is expected, because since this is an entire new course you are going through. Devashish says, I think we should take this in next class. Devashish, we'll have this, just an example to show you how exactly things look like. It's just look and feel. The details we'll be discussing in the next class only, when we'll be going with the hands-on. Does that answer your question? What the job is doing. Okay, see, we have run example command, okay, an example program which is already there, that is known as TerraGen, and TerraGen is used to generate data of the amount we have specified over here. It will generate the data of that particular amount in the directory we have specified. Okay, so Rahul, is that clear to you now? This I'm just showing you to give you a look and feel and nothing more. Do not worry if you do not understand it. I do not expect you to understand it in one shot. Okay, I just gave you a look and feel of how things look like on a GUI and a CLI. What is a map? What is a reduce? We had some small discussion for that. See here for the task tracker. If I refresh it, you will have something appearing over here when the page refreshes. Okay. So are you able to just get a look and feel, nothing more? Do not think on anything else. Okay, just a look and feel of things. Okay, nothing more. Okay, so you can see something written as map 0%, reduce 0%, then map proceeds and reduces proceeding. Okay, you have some job ID over here and all those things. So this is to just give you a feel of how you really write in a map reduce environment. Map reduce is a separate thing that will be covered down the line in the third week. Okay, so this is only to give you a look and feel. Are you comfortable with look and feel? I do not want something that you know all the knowledge and all those things. Sure, Sandeep. If you want to leave and if you want to have a installation thing, you can very well contact the support team. I'll be handling this over to Abhishek. Okay.
Hey Sandeep, not before you answer a few questions, I'll have a quick quiz. Okay, I'll not let you leave, man. Just give me 5 minutes. See guys, one thing which you have to be very, very clear about is that this whatever Rahul showed you right now, right? It is just to give you a look and feel that, okay, this is how, this is the real environment, how it looks like, okay? Whatever we saw in the PPT is happening here, okay? Next session, we'll be covering everything in detail. So by the next session, what you have to do is we'll be sending you an email with the installation guide and everything. You are expected to set this up in your own machine. If you do not have a good high RAM machine, then you can ask for a remote access from the support team. They will be able to provide you that. Okay. But by the next class, all of you should have this installation done in your this thing. And as I told you earlier also, Edureka has a 24/7 support. So anytime you need any help, just drop an email that at 12 o'clock in the night, I want someone to help me out. Okay, there'll be someone who will be present to help you out. Okay, so that is the kind of support they provide. So that way, what I expect from you guys is next class, till next class, read through there will be a installation guide which will be given to you in email. Go through that, and once you're done with it, then we'll do more of practical next week. Is that fine, guys? Can I get a quick yes or a no or a smiley from you guys? Good. Thanks. The only idea here was to give you a feel that, okay, there's something beyond a presentation as well in this, right? You should not say that, oh yaar, kuch practical to karaya nahi. Okay, I'm sorry for using Hindi. Okay, so ये practical करा दिया आपको, दिखा दिया आपको कुछ कुछ, ठीक है? But we'll show you more such things. Gaurav, thanks for that. I actually did it for you only. Okay, thank you, Rahul. Yeah, no, sometimes I mean I am a Punjabi, so sometimes I use Punjabi in between. But I believe, Rohit, are you okay with this? Are you there with me? Okay, Sandeep, before I let you go, okay, all of you. Thank you, Rahul. Oh, performance alert aa gaya kuch to. Sorry. Okay, so before I let you go, I have a few questions. Okay, Syed, see, we have people from different parts of the country. Some may not be able to understand my diction, so I'm really sorry about that if that was not clear. But we'll send you the recording of the class. Please work hard to understand what I taught you today. Okay. Now, I have the first question is here. I'll ask you a question. It will come on your screen. Okay. Is that okay? So can quickly no one has answered till now. Guys, you have to answer it in that window. Okay. You don't have to write in the chat window. That there is a, do you see? Yes, now people have started answering that. Okay, I'll also come to know who is answering right. Okay. Okay, 54%, only 54% people have voted. The others who have not will spoil this country by not voting. I want every 100% votes here. Right, wrong, don't worry. I'll not announce the name of the people who have given wrong answers. Okay. I'm sure there are a couple of people who have still not voted. Guys, please give some answer. If not anything, you'll understand what is the right answer is. There's still one person who has not answered. Who is that? Okay. So yes, the correct answer is remote procedure call. Okay. Some people have probably got it wrong. We just tried to create a tricky thing. Okay, everyone knows what a remote procedure call is. Let's go to the next question. Okay. So let me ask you a question and see if people actually listen to me properly or not. Guys, you have to answer. Are you able to see the poll? Okay, 85% of people have answered. Now, despite my explaining this, I've got some wrong answers. Okay, so everyone has answered. Now, most of the people have got it right. The answer is none of these. Because as I told you, secondary name node is a misnomer. What does a secondary name node does? A secondary name node just keeps on reading from the RAM of the name node and keeps it writing into a file. It doesn't take over in case of a failure. Is that correct? I also told you that in Gen 2 Hadoop, there is something called an active and a passive name node. So the passive name node takes over if there is a failure, right? Right, guys? So whoever got the answer wrong, can you quickly confirm if you've understood it now? Because this is very important to understand. Whoever got it wrong can quickly give me a... Okay, great, great. I'm not going to call out names, so don't worry. Okay, whoever gave the wrong answer can quickly write it that I've understood it now. I want 100% of the people to actually understand this concept. Okay? Okay, great. So most of the people actually got it, but some people could not. So no, don't worry. Let's go to the next question. Now, it's a very, very simple question. If you are not able to answer that, then I'll not take the next class because I'll be thrown out of this organization if you guys cannot answer this question. Is there anyone who's got? Let me wait. If I can retain my job, will I be able to retain my job, guys? Will I be able to retain my job? There's one person who is still in doubt. Guys, please answer. One person has not yet voted. Anupam says, yeah, of course. So I believe there's one person who is very angry with me, who doesn't want me to actually continue with this job. So he has not voted. He has given me a no, he has not voted. So how's it adjourned? I'm really sorry, buddy, whoever that is. I am really sorry if I've taken so much of your time that you cannot bear me for another 5 minutes. But I'll still go ahead. The good part is whoever has answered it right. There's one person who has refrained from voting. Who is that? Can you tell me, guys? Who is angry with me? Can that person answer? Oh, someone has come up with an answer. Well, the answer is Hadoop distributed file system. So DFS is distributed file system. Okay? Okay, whoever got it wrong can quickly confirm that they have understood it now. Okay. So let's come to the next question. Sandeep, are you still there? Can everyone answer this question quickly? I'm not going to call out names of the people who got it wrong because the idea is not to test your knowledge here. Great, Sandeep. Very good. With all right answers. Who knows, you were the guy who did not answer, man. You are my enemy. I know that. Okay. Okay. So yeah. So basically, please all of you answer. I mean, the idea is to reiterate whatever we covered in the session, and I just wanted to have a quick round of questions and answers. Okay, everyone has answered. Thank you very much. Sandeep, I know you have answered it this time. And yes, the answer is Java. Hadoop is written in Java. Okay. So whoever did not catch that point, it's actually written in Java. And you would have seen that when you get that IO exception and all, wherever you get an error, it will come in Java. So anyone who is not comfortable with Java but wants to get into details of MapReduce programming can take these free Java classes, which will start from tomorrow in the evening. I'm sure Rajiv from the team would have actually told you that, and if not, then please contact the support team if you're interested in taking those classes. Okay, let's go to the next question. Syed, it is at 8 o'clock in the evening. Rajiv will tell you, please contact support@edureka.in for that. Okay, now, yes, this is another question which I had asked you. Rohit, are you getting all the questions right, or there is some kuch gunjaish bachi hai? Rohit, are you there? Anupam is getting them right, I know. I feel we'll go wrong. What kind of English is that, man? I did not understand that. Okay. Okay. So most of the people, there are 2 people who have not voted yet. So please, guys, please quickly vote. You have just, this answer will go wrong. Okay. Rohit, yeah, this is very bad. When I explained you this, I asked you guys to look at Google and find out what is the file block size in Unix, and then I told you this answer. Still you are saying it will go wrong. It is big data, guys, big data. Big data means huge amount of data written in one single shot. So the answer is 64 MB. Okay, that is the minimum size. Is that fine, guys? Whoever has got it wrong, 2 people who have got it wrong, can you quickly confirm that you have understood it? Okay, Rohit, good. Sorry for telling everyone that you got it wrong. I didn't mean to expose you. Okay. Okay, Rohit, thank you. But that's fine, right? I mean, we will make mistakes, we will understand it, and the whole idea is that you should be able to understand everything when you go out of this class. And please make sure that when you come back, then also you understand. I'll take a quiz in the beginning of the next class also. Okay. So let's launch one more question. Which node keeps the directory tree? Quickly, guys. Within 10, I'll give you only 10 more seconds. This time everyone is right, giving the right answers. Very good, very good. Looks like Anand. How are you? Heartbeat. Can I get a smiley from your end? You made me make a slide right then. Okay, good, Anand. Okay. So basically the directory structure or the metadata is kept in the name node. Okay. So whoever has got it right, please remember that data node stores the data, and the directory structure and where the data will be stored, all the metadata is stored in the name node. Is that fine, guys? Okay. Whoever got it wrong, can you tell me? Okay. Okay. Good. Cool. Next question. Now this is a rapid fire. Okay. I'll just give you 10 seconds. Quickly. Data node state data in. 3 more seconds to go. The people who are not able to answer are slow. Very slow. Let's see how many people get it right. One more person to answer. 1 more second to go. Okay, stop. Okay. So it's actually the Hadoop file system. In the rapid fire round, some people got it wrong. There's no date. There's nothing called, everything is stored in the file system, right? That's what I told you in the beginning. So whoever has got it wrong, you understand that everything is stored in the file system. Sandeep, that was probably your first question. Where is the unstructured data stored? Is it stored as files? Yes, this is the answer. Is that right, Sandeep? Are you still with me? Or you've left in the Lamborghini? Okay, great. So let's move ahead. Again a rapid fire. Only for 10 seconds. Guys, please be ready, okay? I'll give you only 10 seconds. Please be ready. Here it comes. Sure, Gaurav, no problem. Guys, where are you? People, why are you not voting? Yes, okay. So yeah, I think this time we have a distributed hung assembly here, okay. Some people are saying slave, some people have said master, some people have said none of these. Okay, so basically the question was which node acts as both a data node and task tracker, right? So the answer is slave. For those who have got written slave is right. Anyone confused with this one? Okay, cool. So everyone understood that? Great. Great. So I think we've done a good job today. All of you most of the people have got the answers right. Okay. So last question. I'll give you 2 hours to answer this. Okay. You have 2 hours to answer. Let me see how quickly you can answer. Rohit, can I get the first answer from you? Anupam. It doesn't mean that you'll take 2 hours, guys. Okay. So this is the only question where people have voted for all the answers. Okay. And this is the only question where right now the correct answer is lagging behind the wrong answer. Okay. So let me see. And this is because it was out of syllabus. MapReduce is not taught in this class, right? How can you ask a question which is out of syllabus? Right, Devashish? Anupam says true. I'll keep asking questions, man. I'll keep asking questions which are out of syllabus also, because I want you to actually understand, I mean, think about it, and next time you'll get it right. Okay. So there's no syllabus here. We can ask any question. I will be the name node here. I'll ask any question. Okay. So now there's one more person who is left before answering. He's probably waiting for the 2 hours to get completed. Okay, we got an answer. Okay. See, the number of reducers for the job is determined by whom? It is the user who has the prerogative to set that. Okay. So we did not cover that in this class. Rahul probably touched upon this, but we still wanted to get this fact across to you, that there will be some questions which will be out of syllabus also. In the interview which you're going to give, you cannot say that Erureka did not teach me this. Okay. So there may be some things which we will not teach you. You'll have to go back home, think about it a little bit, do some Googling. Not everything can be taught in this class. Okay. Please enrich yourself with knowledge. We've given you some motivation to learn a few things. Go back, spend some time during the week out of your busy lives and think a little bit more about this particular topic. And next week we'll meet again. Is that fine, guys? Did you like the class? Guys, did you enjoy this? Was it a Mughal Azam or a Savaria? Very much. Okay, very, very much. Both. Rohit Malik says both. Rohit, can you explain how? Thank you, Sandeep. Thank you very much. Rohit is not very happy. I have actually... Okay, don't worry, Rohit. There will be a few things which will be like that. We have a 24/7 support team. Okay, I'll answer all these questions. Okay. Vidya, you can just tell me, did you like or not? Okay. So Rohit, what will happen is that after this class, you'll get the class recording. For everyone, I'm telling you this. There might be a few concepts which are not very clear to you. You may go back, think about them, revise them. Okay. Ask a question on that to the support team. If you want a special session during the week, you can come on Skype. The support team persons will explain you whatever you have not understood. Okay, so we don't expect everyone to understand everything here, but since we have a 24/7 support, that is where it will come into picture, that if you did not understand something, please throw us a question. We'll answer that. Oh yeah. So the Skype ID of support will be sent to you in the email. I believe it is edureka.hadoop. Okay, the Skype ID for this, but don't worry, it will be sent to you in the email. Okay, now some people are asking me, what about the installation part? We'll also send you an email, and all the software and everything will be sent to you. Okay, everything will be sent to you in an email, and you will know what to do. Okay, thank you, Rahul. I did not actually get the answer from my dear friend Anand. Anand said something. Okay. Okay, guys. So don't worry. We will. Sandeep, you can leave now. You'll get an email. So we'll send a follow-up email, Rohit, everyone, where you will be able to get an answer to all these queries. Okay. Thank you, Rohit. Thank you very much. Thank you. Yashwant has made a very good comment. I've seen so many diagrams in this class. I don't know which one will come in my dream today. Yashwant, yes. I also don't know which one will come in my dream today. Sayyid, thank you. Good one, good one. Everyone is appreciating you, Yashwant. You've been adding a lot of humor here. And thank you guys. Thanks for being so participative, and thanks for bearing with me and Rahul for such a long time. And any questions, feel free to send us an email at support@edureka.in. We are also going to create a Google group of the people who have participated in this, so that you can keep in touch with each other as well. Okay? Is that fine, guys? Wait for the email. You'll get the class recording as well. And one more thing, please don't forget to fill in that there is a survey which comes after this class. Please don't fill in to forget. That will not be visible to me and Rahul. You can write all the brickbats there. The team will be looking at it. Okay? Thank you very much. And it helps us in improving the classes further. Okay? Bye-bye. Thank you very much, guys. Thank you, Anupam. Bye, Rahul. Bye, Bye, Anand. Bye, Suman. Bye, Devashish. Thank you, Anand. Thanks, Vidyasagar. You too have a great day ahead. Bye-bye. Thanks, Gaurav. Okay. So all of you guys can leave. Thanks for the long class and bye. What, Samir, you were asking something? Yes, we will be doing a kind of project. Okay, as we go ahead, we will be solving some real life problems. Yes, we will be doing that.